data science recently with all the AI, and even embedded systems. So people is really using this as an example of how to get into different areas and lowering the barrier for people to start doing things in those fields. I mean, before MicroPython, for example, or Scratch, going into embedded system was very tricky. I mean, you need to learn C, and we learned the talk before that people don't like C. And something very interesting as well is the packaging and tooling around it. I think that one of the things that make Python very popular, at least within the Qt ecosystem, is that you could install it by one line command line, pip install PySide6, and that's it. You cannot beat that because I don't know which C++ libraries do you use besides Qt, but I'm certain that the installation process is not as simple always. And something very interesting, though, is that we noticed that a lot of real live applications were combining C++ and Python. I was very surprised that the VFX industry, most of the UIs that are built with Qt, they do have scripting languages on top in order to enable people to have add-ons and extend those things. And also, again, lowering the barrier for people to write some nice plugins for whatever you are using your Qt and C++ interfaces. So this also was very important, a very critical thing for people to start using it more. But this talk is not about Python. If you want to read more about Qt for Python, those are very interesting links. The URL thing will be posted in the channel. So now we can talk about a little bit of Rust. How many Rust developers do we have in the? I was expecting, so I feel now. Rust is not, no, I don't have anything about Rust. So if you're not familiar with Rust, since we don't have many Rust developers, little snippets of code that maybe are terrible written, but at least it compiled when I try them out. So you want to find some similarities between C++ and Rust, so you are not very scared when we talk about Rust. Again, similar thing, you start to see, oh, big difference now, oh, Rust doesn't have classes. But anyway, you can find your ways around to try to implement something very similar to object-oriented programming there. So you are now a little bit familiarized with Rust, so you're not afraid when we are talking about. In my opinion, for example, after all the experience with the many ways of interacting with Rust and Qt, I believe that CXX Qt did an amazing job into trying to be the tool for all the Qt developers that wanted to sprinkle some Rust into their applications. If you know about this project, of course, you can check it out there. But in a nutshell, as it's described, it's a safe FFI between Rust and C++. It's very idiomatic. They use procedural macros in order to generate the bindings. They have also a really cool thing that you can use Rust thread to update the Qt state. And of course, it's still in development because bindings are difficult. You need to do a lot of things in order to cover every single corner case. This worked very well, in my opinion, for Qt developers, for everyone that was aware of Qt. This is at least the problem that I always see in that, because we announce new things and we announce it where? In Akademy, Qt Contributor Summit, Qt World Summit. So everyone knows Qt. So you are like, yeah, maybe another language that I can try, right? And even for KDE developers lately, I have been very happy to see that at least a lot of people has been working in also the integration of enabling people to write a Kirigami application with Python and also with Rust. So if you are interested with this, there is a session later on that I'm very interested. Yes, so Nicolas there. So there's a question in the title, so I'm really curious about what is the answer. Maybe yes, maybe no. So yeah, if you're curious about that, it's something that also has been very important in the KDE ecosystem. But then the question is always, what about everyone that is not aware of Qt? And I'm sorry to break this to you, but there is a lot of people that have no idea that Qt exists. And this was a very like a cold water bucket that the first time that I started to go to Python conference thinking that everyone knew the Qt framework was so old and everyone used it and PyQt existed before. And to my surprise, when I was asking in this audience, like, who knows Qt? Literally 5 hands at most. Because most of the new developers were not very familiar with it, and there were many other frameworks, at least in the Python ecosystem, that were offering things for them to build small and simple user interfaces. Because we know that Qt is very good for professional development and everything else, but most of the people starting programming, what do they want to do? A little calculator, a button that does something like that, or even exposing some data to have a nice desktop application that can help them to, publish some little software and stuff. So it was very strange for us. So it was at least giving us the idea that we might need to explore other ways of bringing Qt to people. I want to go back to the case that we had before. How many people here is familiar with Python code? Okay, many of you, and is familiar with PySide or PyQt? Okay, still a few hands. So when I showed you this before, and we showed specifically this code, you, as a Qt developer, you will read this and say, everything makes completely sense. But now try to put yourself into the mind of a Python developer that have never seen Qt. You are telling a few things here. So first of all, yeah, it's normal for us that you will be inheriting from some Qt classes and implemented some methods. You need to understand how the Qt API will work. By the way, don't forget to connect your buttons with this to a slot, the signal to a slot, and also in the case of Python, you need to decorate your slots with the slot decorator that, of course, is come from Qt Core. And yeah, by the way, this is an application. You need to start the event loop and make sure that you are exiting as well with the app exit, the same return code. You are asking Python developers to write a Qt application from scratch, which is completely different to most of the cases, like I have my Python code and I want to have some application user interface, right? So this idea is something that was bothering me and many people, at least in the Qt project overall, that we need to really start to think like what else we can do about it. So as I said, this might feel very not natural and a lot of extra work for people to start. Even time to time, I get questions like, hey, how can I get started with PySide in Python forums? And it's like, oh yeah, read the tutorial. But the moment they start to read and they see all the signals, slot, whatever, everyone gets scared. So we need to try to think like how we can expose this thing. There are other things as well that when we are exposing Qt and C++ in general as a binding for other languages, we are kind of like forcing that language, like, please tell me how to do these things. I always try to put the example that everyone is familiar here with a void star, right? What is that in Python? We don't know, right? So we need to try to, yeah, well, this will be a pointer, a reference or something. You need to start to figure out and forcing the language that maybe is not designed to that to understand this concept and try to interpret this concept. And this is very complicated. So then the question, how can we include other languages without breaking all these paradigms for languages? I believe that, in our opinion, it will be this new idea that we have, which is called Qt Bridges so far. I don't know if this is the final name. This was recently announced in the Qt World Summit as one of the new research projects that we have around bringing more languages into the Qt ecosystem. I never see names in technical slots. I just want to give it a shout out to the team that we have at the moment. Recently, a lot of people got involved of the initial 5 people. But maybe you recognize one of those names maybe from Gareth if you are contributing to Qt. But yeah, in case you have any questions, you might have seen the PM of the project, which is Vladimir, and I am currently the technical lead until they'll fire me. Now, there are more people involved as well, people trying to think about what is the best way of showing and having documentation for this kind of project, because now it's not only like, you know, Qt C++ API. We need to mix a lot of things, and languages have documentations in different formats. You need to parse them. Should we use QDoc? Should we use the local thing? There's a lot of decisions to make. So the new approach, I tried to steal this diagram from a previous Contributor Summit presentation. Usually when you have your application, the language bindings are something kind of like in the middle where you can kind of touch what Qt is doing by the language, as we saw before, trying to have these Python classes or everything from the application itself. But the concept that we have with bridges is that we want to really split the idea of your application and the UI that you will have. And this will be with this middle layer that you see there, which is called a bridge. So as I said, splitting backend from the UI, mostly because we want to reduce the Qt footprint from the backend, and we want to have people maybe in a situation that they could have the same application written very similar. And also, we are still working on instantiable types as well by using some QML private API, because why not? But it's still in progress. So the little implementation detail that we have here is that at the beginning we were envisioning these ideas. We thought, nice, so we can have the same code that just changed the code and everything should be the same, only maybe changing the, I don't know, brackets or something that the programming language will use. But then we noticed that, well, not really. because the concept of each language will be completely different. Like while in Rust we're using procedural macros, in Python we might need to use decorators, or in other languages like Swift we might need to have observable types. So even though it would be nice to have like a little tab to change and it's the same code changing in 2 lines, the whole implementation is completely different depending on the language. Another thing that we are still envisioning and still working on it is that the package distribution is something critical. I cannot tell you, and I hope my employer doesn't listen to me, but I cannot tell you like you need to go to the Qt installer to install the package in Swift, and then you need to export it, and then it makes no sense. We need to play with the rules of the new programming language that we want to. If you want to go to Swift, do what Swift people do. If you want to go to Java, do what Java people do. So this is very interesting for us because so far we are exploring, as we knew from Rust, from Python already, but for other options as well, like C#, like having nugget packages, so configuration that the C# developers can feel comfortable by developing in this thing and not forcing or imposing the way that we are all supposed to do it, right? Similar to that, development environment, it's something that I have been personally struggling with, because even though we love Qt Creator and we have adding support for Python Qt Creator, I know that Python developers don't use Qt Creator. Some of them do, but again, if you want to play by the other programming language rules, we need to go with other programming language R. So if you are using, I don't know, C-Lion for your C# development for some reason, or for C development, whatever, we go there. PyCharm, Rust Rubber, anything. We might need to have this thing in mind that we need to provide ways for you in your development environment to develop these applications, which is very hard because also we need to do plugins there. So different languages, different IDEs for sure. I know, just again to know your opinion about it, how many people here is using Visual Studio Code? Yeah, still kind of half, what the majority? Qt Creator? I like your pride, I'm like, yes. Good. So see, different scenarios, different realities for everyone. I really don't want Visual Studio Code people to go to Qt Creator, or Qt Creator people to go to Visual Studio Code, and so on and so forth. Something very important. Since we announced this new project, we have been getting a lot of questions of like, but how can I do like whatever? So even if I hope you don't feel excluded by the target users of this project, as I told you before, are new developers, right? You can try, you can join, you can do a thing, but it's most likely that not everything that you're used to do with Qt will be able to do with Qt bridges. Because our goal, of course, to expand the communities. Because otherwise it would be an echo chamber if I present you new something here, some of you try it, yay, then we high five, continue next year, some people try it as well. We are not bringing more people to the room. So it's very tricky. A sneak peek then. I will show a few snippets of code. As always, they're not final. You might not be able to read it. I tried to put it in the slide so it is visible, but you can see the URL afterwards. But yeah. So one of the first examples that we did, we have more, but just to try it out, just to have the proof of concept of this, was a simple application where you can add some strings, you can remove them, you can edit them, and it doesn't allow you to get duplications of those strings, right? So you see here the QML code. So not so, well, it's a bit long, but it's not so complicated to understand. And so then we will figure out how a backend for this thing in the many languages will look like. I hope you can read them. So the first one is C#. By the way, I discovered this is the logo of C#. I was using the old one, and apparently this is the new one. But anyway, if you're unfamiliar with C#, simple function on the left so you don't get scared. A few features that if you were curious about it, most of the memory management, it's interesting. Being kind of like very type safe and having struct typing for Windows, and being kind of like the first programming language that Windows development uses. There are many other, like the standard library they have is quite large, sorry. And they have many features as well, like in many other languages, async await, generics, lambda expression, whatever. So the reason that, at least in my opinion, that we choose this C# is because, again, still C# is the king in Windows development, so we don't want to neglect that, even if most of us are using Linux. We need to, of course, include people that are using Windows for some reason. And yes, we had some experience before that there was this Qt.NET. Maybe you have heard about it, you have seen it before. Some people in the company were playing around in order to integrate .NET and Qt applications. The .NET ecosystem is very large as well. They have their own conferences. They have old events and stuff. So yeah, more people around. on. And even the tool is not the great, in my opinion. It's very useful compared to everything what they have with Visual Studio and all the other things, Nugget packages. So this is how it would look like. I'm very sorry if you cannot probably read, but as I said, later on you can check the URL. You have here on the side, you have like a class backend. You are implementing with some unique string list model that of course is implemented in the bridge side. And then you will have a few functions that is add string, duplicate found handler, one duplicated found. But as you can see, and you can spot the Qt mentions on this code are quite minimal. So you have an namespace, an import, and of course the model will have something here, but everything else is C#. And the main, of course, you need more Qt stuff there, so you can load the QML file and try to wait for the event loop to finish. So reducing Qt footprint in the code that is using as a backend. So we go for Swift. If you're unfamiliar with Swift, again, little code there so you feel more comfortable. Safety and performance, modern syntax. It's a very interesting story. I mean, I was not very familiar with Swift, and when I started to read like how the whole thing started or the people involved in the language was like, whoa, okay. But it's really cool. They have an interpreted mode as well. And again, after all the features and things that they have, the reason is that it's still the default language for macOS development. Because again, people doing that, they just open Xcode and they start to do things, or people doing iOS development. So there were some previous effort. I remember a couple of World Summits ago, I think one of our colleagues, Torarne, was showing me a new test that you can find some Swift code into related to a quick application. And I think it was translated afterwards in a test. So, well, we had some at least know-how that, of course, you can link them together. And internally at Apple, they have been pushing a lot for Swift to be more like a good programming language for Linux and Windows. I don't know if you have tried them. At least I tried on Linux and it worked. But on Windows, I have no idea. So again, we don't need to neglect. If you want to go to Apple developers overall, we need to try to go and play by the rules. Similar idea here. As you can see, things are starting to change. We have a little bit more of cute things on the left side. There is now a decoration here on the class Qt Bridgeable, and then we have a couple of observable types, and then edit string, add string, but again, nothing else that explicitly have Qt code. So a Swift developer can check this code and say, yeah, that makes sense. Only this little decorator on the top. Of course, for the starting the thing, you need to have, of course, more stuff. Like the list model is something that is provided by the bridge, and then you need to deal with setting the root for the QML and launching the application. But we believe that at least this is completely an improvement compared to the binding situation. The videos are not being reproduced. I had some little videos after each language, but you will see it if you open in Firefox. I think that this might not be. But you have a little demo of the code being compiled, and then the application popping up and doing some stuff, but I'm missing those. Java, don't go. Please, I know it's not the most loved language, but it's very used, and you cannot neglect this. I mean, having a more heterogeneous community also implies that we might need to include languages that you might not like, but maybe they will be a good user base with new ideas or things how to improve this thing. So if you are, for some reason, you are not familiar with Java, a little code on the left again. Well, I will not say many things. I mean, I guess that everyone will be familiarized with it, but no. The memory management they have, all the platform independence. I think I was also even doing the Java applets at some point. Why? I don't know. And yeah, they have like good security, at least with the bytecode verification, which is a feature that I really like. But yeah. The main idea, at least, that why we picked Java is for the experience that we have, because in Qt, you know that you can develop for Android. And also, similar to Android, we have some offerings regarding Qt Automotive that also mixes some Java as well. We have a project that also we're generating some code called Qt Jenny that you can check out. And as I told you before, there is an active third-party library that allows you to have bindings for the Qt project, which is very interesting in my opinion. So it is something that is important, and at least we cannot neglect it. Here is how the code will look like. These have a little bit more of Qt-related things, because as I said, languages implementing differently. You have here at least some declaration to the class, a special callback, which is nothing else than an interface that we have here, the state, the model is, but in a nutshell, at least you can see that the add string and update and remove are something that could feel very familiar with Java developers. I still get nightmares about how you need to declare the main in Java. But anyway, again, video that you will see later on because it's not here. And another interesting feature is that you get kind of for free the Kotlin interoperability. Who knows Kotlin here has using it? I guess that you all feel that there's a language that was created from Java developers that wanted to have Python, and then they said, we cannot have Python, we have Kotlin now. No, but it feels very comfortable at least, and that's a good thing because then we got a new language. I mean, there are Kotlin conference and stuff, so more people that we can bring to the Qt ecosystem. So now I want to talk about Python, and you will say, wait, why? Because you already had Python. But yeah, well, it's a different story. So again, most of you are familiar with Python. I will not bore you with all the different features that the language has. But most of our motivation, at least for picking Python as a language, is that we had a lot of experience with Q for Python already. The whole binding generation process, the reiteration of QML types, is still the most popular language according to those two surveys. If you have another survey, let me know. I can put it in the slide, but still the most popular language out there. And the interoperability with many technologies. I was briefly discussing before that currently in the Python ecosystem, if you're not very close to it, a lot of people is rewriting a lot of tools in Rust. For some people, it's like, what is faster? But there's a lot of like Rust things happening within the Python ecosystem. So it's a very good thing that we are still around with both languages. Again, this is the application that you might see. You are saying, wait, but this is way longer than you had before. Well, kind of, but if you really close look the left code and you start to search for Qt-related things, I think that the only one will be this one, this line. Everything else is a normal Python class. Everything else is just Python properties and so on and so forth. So we don't have anything Qt, well, besides, of course, imports for launching the application, but we reduce a lot the footprints there. So video there, imagine a Python application being launched. And Rust, similarly to the Python story, I don't want to worry with all the features of the language, so we maybe have some time for questions, but as you know, very popular programming languages, safety being kind of like one of the main pillars of the language, so I guess that everyone wants to start using it. In my opinion, one of the highest thing for me is that Cargo is an amazing tool, at least for my experience. I love to have that in more programming languages. But yeah, Rust again, and you might think, well, but you had CX-Execute similar to what you had with Python. Yes, well, there are some experience there. And one of the points that I wanted to make is that we believe that both C++, CX-Execute and PySide are perfect tools, frameworks for Qt developers to include those languages to applications. But the whole idea of this, as I said before, and I will sound like a broken record, is to go for Rust developers and Python developers in order to bring them to the Qt ecosystem. So as you see, Rust is very popular. That's why KDE even is adding bindings for it. And the ecosystem is growing like crazy. And as I said, tooling is my favorite thing. Again, how it looked like, sorry for the small font, but you can check it out afterwards. We have a couple of procedural macros there in order to expose the backend. You have the data also doing here some very Rust-related things. For the slots, we'll see are using a macro. But again, the footprints that we are, the Qt footprint here in the code is quite minimal, again, compared to CX-Execute, for example. But again, different functionalities, different use cases. So again, video, imagine the Rust application being popping up. A note here. I'll show you some snippets. These are still internal. There's most likely will change. If you have idea, you can always talk to me. And also, it's one specific example. I told you before, we're working on instantiable type for QML. We have like maybe 2 or 3 more demos or examples that we want to have ready in order when we have the release. So yeah, don't take this as the final word. So brief. Frequently asked question based on all the comments that I have been getting from people. Maybe you have more, so feel free to do that. So we can go there and do a little tour there. But I need water first. So, first one. Maybe you will, I already saw some angry faces. What about this language that I use and it's the most important language ever? Well, one of the things that we want to enable is that maybe we can have documentation well enough for people to start adding more bridges to the offering. So if you have any favorite languages, and these are all the languages that we have kind of like here, people like, oh, but what about, they are there. Bonus points if someone tell me which language is this one. Good. Yeah, Gleam. Amazing programming language. Go and check it out. Another question. What about this feature that is essential to all Qt applications, and if you don't have it, this project will die and you're wasting money and whatever. So again, the scope of the project is important. There might be many features that are missing. Maybe we will start adding it, but it really depends of the use cases that we have in mind. And as I told you before, like 5 times already, it's mostly for people to feel like they are doing things in their own languages. So many things might need to have more Qt intervention or more Qt related isms in the code that might not be very positive for the experience, but let's see. Maybe the thing works out and we add more things. So what if you need more? It's not enough to just populating some list of strings, because most of your applications, I hope, are more like displaying a list of strings on a UI. Well, in that case, the idea will be to direct people to all the set of bindings that we have. If you want to do more with Rust, you do CXX Qt. If you want to do more with Python, you do PySide, and so on and so forth. Or if you want to go back to the old way, you go and write everything for C++. Well, it's not the very encouraging for new users, but at least we are giving the entry tools for people to start doing simple applications. You might think, so you are not developing more bindings? Yes, the development bindings will be still ongoing because, as I said a million times already, different use cases. So why is only Qt Quick? Because we love Qt widgets. Well, again, I don't want to go into that framework, but we believe that, of course, Qt Quick is kind of more modern and attractive way of creating UIs. To my surprise, many new Python-related frameworks are using declarative files in a way to define the interfaces, so it's something that is still getting around. So will you support everything that QML can do? Well, no, again, it really depends on the adoption that we have with the project and the use cases that if we want to make them valid. So don't expect every single feature from QML to work. Can you combine all the languages in one application? Well, not really for the technical preview, but maybe if you're brave enough, you can give it a try, but at least what we want to aim is to have at least the interchangeability of the backend for the different languages. Do you want to bring C++ developer with this project? Well, exactly. Will this be open source? Of course, I believe that that's the key for getting anyone, because if you put a lot of fences between people, nobody will jump into this thing. So we need to play by the language's rules, where they do, conference they go, package manager, ways of installing everything in order to bring more people to the community. When this will be released? Well, we initially thought that the release will be around November. We still don't have a fixed date, but we expect to have at least a first technical preview this year. Famous last words. No, but we hope. So to summarize, what does it mean to have more languages with Qt bridges? I really, really believe that means that more communities can get together. We can have maybe a larger Akademy in a few years. More ideas. I have the feeling that every time that we look into other programming languages, when you get weirded out, like why they are doing, like, oh, they're doing it because of that. You get these ideas. And you can see this thing in C++ 23 or 26, that there are many features of the languages that, of course, come from other programming languages. So inspiration is very cool. Even for the Qt ecosystem, I think it will be crucial for not getting into the same level and having more new stuff around. New expertise, of course. You will get experts in the language that will tell you that no, the way that you did it there is completely wrong, or yeah, oh yes, that's the way that we do it, so thank you for that. So new faces and new people contributing. And another thing, of course, is that better ecosystem, in my opinion. If we have more languages, we can have different opinions rather than having like only a fight of, I don't know, 2 programming languages. We can fight about 6 programming languages. So it's even better. And the most important thing, of course, as I always want to say, is that, is that I want to bring Qt everywhere. So thank you very much, and maybe you have some question now.
Awesome. We have like 5 minutes, so who'd like to go first? I think. No,
Hi, thanks. Can you give some examples for things that are not going to be part of the use case, or what you will be able to do with Qt bridges, and perhaps the rationale for why? No. Just you won't be able to use the Qt network classes to build an HTTP server because Python already has stuff for that, or something like that.
And I was completely against of exporting Qt network and all those things, and there was a lot of Qt developers that, no, I need the Qt API to do this thing. I don't want to use Python, HTTP and stuff. But yeah, so far, at least the other use cases are mostly around item models in general. So this is at least the starting point that we're having for the TP. We have a couple of other demos, but in a nutshell, it's kind of like exposing a little bit of data between the Qt Quick and the other languages. So besides this use case, we don't have many more so far. But if you have ideas.
So one question from the chat, which relates to the fact that we're here at a KDE conference. Is there a way to use some existing Qt-based C++ libraries like KDE frameworks while writing most code in another language?
That's a great pitch for my talk. Then I will play the Nicolas card, and then Nicolas can reply that afterwards.
I have a statement and a question. The statement, as a representative of the CXX Qt team, we are very impressed by this. We think it's a great idea. We're working together on making sure that we have a shared base library of types so that you can extend things you have built with the bridges by way of CXX Qt. So we very much think these things are complementary, orthogonal, and we are working with Qt Company to make sure that they work well together. Particularly in KDE, I think this will be important because you guys will want to use probably more than just QML and list views in other languages, and Rust specifically. The question is, you've chosen to take a runtime approach where you're generating everything basically dynamically at runtime. And I know you've done that in Python too, and it seems to work there okay. Are you worried at all about the performance impact of that?
I'm getting my exercise today.
Yes, of course, yes. I mean, there are other issues as well with performance related or even times. For example, in C#, we currently are dealing with a thing that we are generating a lot of code, so we have a longer compile time, as you might be familiar because we talked about it already, similar to the Rust ecosystem, like doing this thing at runtime might be something that the Rust people will say, why are you doing this? But yeah, that's a thing that our goal first is just to put the TP out and maybe have how people feel about it. Because at some point you might find people that say, well, this is taking longer to compile or the whole execution or something. But at least I'm getting something nice out of it. Some people might not say that, or say, no, it's impossible if it doesn't compile or do something in 1 second, then we don't use it. But I think we will kind of like, are expecting for the reaction of people firstly, before trying to push the patch before the wound. But yeah, it might be also a lot of time.
So I think we have one more, and I'm not running.
Sort of related to Till's question about the runtime aspect of it. A lot of the recent improvements in Qt and QML were around the QML tooling knowing better about the C++ types and being able to do autocomplete for like properties and types defined in C++. Are we going to lose all of these improvements when we do different languages with runtime things injected and less of that compile time thing that's happening right now?
Yes, we are killing the QML project. No. At the beginning, of course, we might see some issues there. But I am certain that Fabian and the whole team will be more than happy to apply all the same performance improvement to all the other languages. Right, Fabian? Yes, see? He was. Yeah, but it could be that happened. I mean, that's the thing that we want to do the TP just to see what is the people reaction. But yeah, it could be that in the future we need to improve it further on. There's another question, but I don't know if we have time.
We can just squeeze it in.
And it's a little bit of a trollish one. Are you going to do a bridge for C++?
You need to add us to Volker if you have time enough after the QRange model. Maybe now you are ready to have the official bridge for C++. No, but why not? I mean, it could be something that we can minimize the boilerplate code because we have a lot of boilerplate in Qt. So maybe, I don't know, if people get motivated enough, then this can be something for discuss for the BOFs in a couple of days.
Awesome. So if we can all put our hands together for Christian. So we have a coffee break until 3:30. Kevin and Arjan, can you come and see me, please? Hello. Can everybody shift across in their rows so there's space for latecomers to get in? Always happens. Thank you. Okay. Now the next talk will be Arjan with the State of the Union.
Yes. Hello, my name is Arjan Hiemstra. I have been a KDE contributor for a while now, and have been working on a project called Union for also a while now. And I will be giving an update on how that's going. So, to start off with, let's talk about what is this union thing again, because I'm sure most of you here know it's not like the workers' union thing, it's a programming thing. Several years back, I, along with several other people, concluded that we have a pretty nasty problem within KDE when it comes to our styling, which is that we right now have 4 different implementations of what we call Breeze. We have the widgets implementation, we have a version implemented for Plasma, we have a Qt Quick implementation, and we have a different Qt Quick implementation, because of course, why not? This isn't mostly a problem because, yeah, oh, wow, okay, that was, that was the wrong button, apparently. What kind of language is this keyboard? Yeah, I mean, I guess we're just skipping to the beginning. Spoilers, yes, I'm sorry. Yeah, we're at the beginning and again, so I can take it back here. So, as I was saying, the problems with this being, if you want to change anything right now with regards to Breeze, you are stuck doing 4 different kinds of implementations for that change. And I'm pretty sure everyone here will agree that, you know, doing the same change 4 times feels like a lot of unnecessary work. The other problem is some of these implementations require a lot of developer knowledge, especially the Qt Widgets one. It is painful, even for me, to make changes there, because it's not just that it's Qt Widgets code. I don't like writing Qt Widgets code, I will admit. But it's also that it's very specific type of Qt Widgets code that really requires you to know how the class called QStyle works. So yeah, it's painful, and if you have a designer coming in with, hey, I have this amazing idea, they quickly get turned off because us as developers say, yeah, it's cool, but sorry, this requires 4 implementations, and we need someone who knows how this QStyle thing works for that. So a lot of this gets bogged down in technical details. And one of the other bits about this is, so we have one of our styles using Qt Widgets for rendering Qt Quick stuff. And that's not ideal from the Qt Quick perspective because it doesn't actually make use of a lot of the features that Qt Quick has for its scene graph, which is actually how the other Qt Quick implementation came about, but that's a different story. All right, so this was identified like 5 years ago already, but it's a very hard problem to solve. I mean, we got into this state for a reason. Getting out of that state is a lot of work as well. So at some point I did some thinking and came up with this idea about, hey, how about we define, or we pull back a little, and rather than having either a Qt Quick style that makes use of Qt widgets or a Qt widget style that makes use of Qt Quick, which was suggested at some point. How about, rather than that, try to define a core data structure that both implementations can use? So that's how I came up with this idea of having 3 layers. An input layer that generates a data structure, and then a data structure that can then be used by output layers to style things based on whatever that specific part of the platform uses. I did some proof of concepts for that. It seemed to be working. It felt like a right idea, so last year somewhere we started doing a more production-ready implementation for this. But that did mean we needed a plan, because trying to build this entire thing where we go, yeah, we have 4 implementations and we throw all of that out and we have this new thing here which will be amazing immediately, yeah, that's a recipe for disaster. So let's see if we can come up with some smaller steps that we can take so that we slowly can go into this state where, yeah, we have this implementation that's now become obsolete. Oh, and then we have that implementation that's become obsolete, etc. So my main focus has been on Qt Quick as output, building a Qt Quick style. For, again, I much prefer writing Qt Quick code over Qt widgets, so it's partly personal preference. It's also, I feel, a bit easier to some extent, and we have a bunch of implementations on the Qt Quick side that we can make obsolete if this works out. And one of the things I decided initially was to use Plasma's SVG theming as an input format. Because this was something that we already have and something that we know how it needs to look. So it meant that we simply needed to consume that and send it through this intermediate layer and then create a Qt Quick thing that outputs that. Both of those sides being known. So it meant that we could focus on that data layer. Yeah, so focus on the data layer, focus on that intermediate layer, and later on worry about, hey, is this actually the right choice of input or output? So that gets us to a year later, about a year. I don't recall the precise date of Akademy last year, but a year later, where are we now? Well, I'll start with some images. This is Discover. This is Discover running with Union. And I think most of you will look at this and think, that just looks the same. Which is the intention, don't worry, because this is also Discover. And I know this looks horrible, but this was a testing style I did to make sure, to give me myself an idea of how much control do I actually have over Discover from the style at this point. So for those of you familiar with Breeze and everything, this is not just a color scheme, because there's some details here that are different. Like a lot of things are missing rounded corners. Cards have a very different styling, both without and with hover and everything like that. So basically, this screenshot is proof of I have control over how Discover looks from the style. And also, I will note, I did not touch a single line of Discover to make these changes. So, current state, Qt Quick Controls. We're working on building that style out. There's a bunch of stuff that's already working, like most of the basic controls that you would use in an application. There's some bits and pieces where we still have work to do, most notably table controls, and there's some calendar-related stuff that was added in Qt 6 that still needs styling. Funnily enough, as far as I know, none of our other Qt Quick implementations have styling for those calendar controls yet. So if we can get that into Union, Union will actually be the first to provide a Breeze style for those things. An important thing to note here, Kirigami. We have I wrote the usual Kirigami integration points for it, but also I created a bunch of things. So the custom controls from Kirigami are actually under control of Union, which is something that if you've ever seen a Kirigami application running on a different platform with a different Qt Quick style, you'll notice that the cards, for example, will usually still look like Breeze. That's one of the specific things I wanted to fix with Union, to make sure that the style controls the entire application. Kirigami is, there are still some issues with some of the controls. I'm basically doing something with Kirigami that was designed but was never fully tested. So there's a bunch of controls that we run into where the template basically doesn't do enough, and the actual control does a whole lot of stuff, which means that if you're then re-implementing that control, you also need to do all of that. It's fine, it will be fixed eventually, hopefully. Some notes on the Qt Quick side, Qt Quick API details. I've included a snippet here of what one of our style implementations looks like. On the Qt Quick side, most of this is controlled through attached properties. There is an implementation of a custom renderer for rectangles, because there's a bunch of features that I needed there. I'll talk a bit more about why that is later. And I implemented a custom layouting thing so that the style is actually in control of how certain sub-elements are placed. This was to deal with spin boxes, for example. Spin boxes on different platforms and with different styles will have different positions of where the up and down or plus or minus buttons are placed. And I really wanted to be able to give that decision to the style. That's all working now. And as I was saying, we have an initial implementation using Plasma SVG. That required a lot of extra information because Plasma SVG turns out that SVGs only only contain graphical data and not really information on, hey, this element should be used for this border and this element should be used there. So we had a whole bunch of extra stuff around this to basically encode what in the current implementation of Plasma theming, the Qt Quick Code encodes, it worked, or it works. It's not ideal. So somewhere at the start of this year, I made a decision that this Plasma input format was not gonna be future-proof. I would not be comfortable releasing a version of Union using Plasma SVG as input, because it would not be future-proof. It would basically be saying, yeah, here's this cool new thing, but you can't do anything with it because, yeah, you can't do anything with the input layer. So instead, I went and spent a bunch of time on something that I've originally already wanted with this, which is to use CSS. And why CSS? Well, I had some requirements for the input layer. And very specifically, one of the explicit requirements here is that there is no logic in the input layer. Having logic there would make the data flow extremely complex and would make it very hard to cache anything from that input layer. So basically, at the design phase, I went, okay, no logic in the input layer. Also, I want something that is easy to change for non-developers. So it basically should be a text file that you can edit to get different results. And it needs to be something that is extensible, because as already mentioned, like Kirigami controls, I need to be able to style those eventually. Plasma has a whole bunch of different things. We probably want to use this at some point for Plasma, so those need to be able to be supported, etc. So, who here has never seen any CSS? Yeah, so CSS is a very well-known language. It's very actively developed, a bit too actively sometimes. But it's also designed in such a way that it abstracts, it's an abstract description of a style, because that's how HTML uses it. That's all nice and such, but there's also some other sides to this. Because of how it's used, a lot of CSS is geared towards web usage. And more importantly, that also means that most of the implementations of CSS are tied to web browsers and web engines. With a few exceptions, if you look around, like for C++, CSS parser libraries, you'll get a few hits. Most of those are hits of libraries that are no longer maintained and implement some version of CSS2. Whereas right now, I think we're at CSS 4-ish already. So this is a problem, and this is why I chose to initially work with Plasma SVG rather than going for CSS immediately. Well, luckily, there is one project that kind of stands out from the rest, which is called Servo. Servo is a Rust-based web engine created by Mozilla to, I think, originally to replace Firefox's rendering engine. That never happened, but still, the project is there. And one of the advantages of Servo is that it's actually designed in a fairly modular way. Most importantly, for our case, there is one Rust crate, which is called CSS parser, which ostensibly implements a CSS parser using Rust. or that's at least what the name suggests. It's part of Servo. It's used by Servo to for their CSS parsing. It does support a whole lot of modern CSS, but it's actually turns out that it's quite a low-level library, and it's a parser, yes, but it's a parser that basically gets you a bunch of function calls where you go, okay, yeah, now you need to do something with this data. Which, you know, I guess it works fine if you're Servo, but if you want something where you're like, okay, I need to get some sort of abstract description out of this CSS file that I can then transform into something that my style can use, it's not that great. There's also a bunch of CSS, modern CSS features that it just goes, yeah, you have to implement this yourself. Luckily, there are some bits and pieces, extra crates that allow, that help. Most importantly, there is a selector parser library or crate that's also done by Servo, which takes care of the entire parsing of selectors. That saves a lot of headache, but there's other bits where I basically ended up writing still sort of my own parser, simply because that's what the crate didn't implement that. So there's also the other side of this. It's great. It's you know, this thing is available, but it's Rust. And Union is basically a set of plugins for Qt code, which kind of requires it to be C++. Luckily, there is some stuff that helps. Specifically, there's the CXX crate, which in this case I decided to, okay, let's create my own library using CXX with a very thin layer for a very thin CSS or C++ API, so that I can use Rust for most of the actual CSS parsing tasks and just kind of output this abstract description of what the CSS file produces. So that's what I eventually called, by the very creative name, CXX Rust CSS parser. It's a library that basically allows you to take a CSS file, have the Rust code take care of the parsing, and then get an abstract representation of the contents of that CSS file out of it, so that you can then do stuff with that. Like, you know, build a styling engine. So, great, we have that thing, we have CSS. How do we make use of CSS for styling our applications? Basically, how do I transform a bunch of things like this kind of gobbledygook? How do I transform that into something that the application can do stuff with? So one very important concept in CSS is selectors. Selectors basically say, hey, this is a query to your application. If something matches this, you do something with that element. Me personally, I knew because I kind of was hoping for using CSS for Union anyway. I kind of stole this idea from CSS in Union because it's a concept that's just very well applicable to what Union is trying to do. So Union has the exact same concept, which meant that, you know, doing this from CSS, that's easy to map. So as an example, again, here's a bit of Union's Qt Quick API. It basically says, hey, if you're a button, then I declare that this is a button and some states, and then there's some of the possible CSS selectors that allow you to target this specific element. Either very generically, like, hey, every button needs this styling, or specifically the pressed state of a primary button needs this styling. So the other thing is properties. Properties tell your application union what to do with an element. How does it change when this rule applies, when the selector applies? This is where things get a bit hairy with regards to web. Web CSS has a whole bunch of properties, and a whole bunch of those properties are not applicable to Union or to an application in general, because they say things about how certain layout stuff happens, or things about overflows and such that just really don't map nicely. And this is actually the reason why I wanted more of a low-level CSS parsing library for doing this, because I wanted to be able to, from Union, say, these are the kind of properties that we support. Because, again, some of them just don't make sense. So we still need to know what those properties are. And luckily, modern CSS, I think it's very modern, I don't even know if it's official standard yet, does have a syntax for declaring properties. And I realized that I could just use this same syntax to declare all the properties that Union would need. It would mean that you need to load first one CSS file that just defines these are all the properties that we need, and then with that it can then parse all the rest. And that turned out to actually work really well. I think that works a lot more, it's a lot more flexible than having to worry about designing an API to define properties in the parser before loading a CSS file. So the other bits is important in CSS is functions. This is one of the areas where the CSS parser crate really, it kind of disappointed me. Basically, all of the function stuff in modern CSS, if you use that crate, you need to re-implement it manually. Even vars, which are basic, more of a parser thing than really a function call, even those you need to re-implement. And that was a lot of work. So that is a lot of work, which means that there's a lot of stuff that in CSS functions that has not yet been implemented. It does give us some flexibility, because other stuff, like having a simple linear interpolation function, was something that we could add. So, in conclusion, I switched to CSS for input for Union. I am, despite the issues with the crate, I am very much, I think it's a good choice. It's a choice that long-term will benefit us. It means that we have a language to work with where we can say, hey, we have this thing. If you want to build a new style, here's the documentation on CSS. Go wild, see what works, see what doesn't. It will there will be changes, but it will not be a dead end. So, with that, what's next? Well, obviously, this needs to go to users or at the very least, developers, people who like testing this thing. So we need to make a first release. I had hoped to be able to do this in conjunction with Plasma 6.5. Unfortunately, that's not going to be feasible because there's too much that still needs to be implemented. Hopefully, we can do a release somewhere between 6.5 and 6.6. We'll see. It will contain a CSS version of Breeze, which means we'll now have our 5th implementation of Breeze. Hooray! The thing is, one of the things I hope is that this implementation can actually start replacing the Qt Quick to Breeze style already, because it should do mostly the same as that style, except with a different backend, and in a way that is hopefully more scalable towards the future. So the other things are, I don't think many of you were not at Andy's talk earlier about Plasma Next, but Andy's been working on this project for a while now, and it really wants to build a new application style using the design system they're developing. And it's kind of stuck on Union getting to a state where they can start developing, this can be developing with, because otherwise they would also need to do 4 implementations of that style, and finding some developers for all that, it's a nightmare. So hopefully we can start building on this soon. It will probably require extra development in Union because there's several features that I know aren't yet fully supported. But we'll see how that goes. Yeah, so there's stuff that I have not yet implemented for the CSS part there. Those will eventually need to be supported for it to be fully, to work like a lot of people would expect from CSS. And especially more fanciful, advanced styles will require features like gradients or textures. And one very important thing that is not yet implemented is animations, which is its own kind of worms. And then there's other output formats, most prominently Qt widgets. There is a merge request from Joshua Goins, who started a very initial implementation of a Qt widget style, which means, so I know it works, but that still requires a lot of work. And there are potential other targets within KDE. We have decorations that are right now hard-coded, or do their own painting and everything. Stuff like that might also be a good target to eventually unionize. And now we do get at the question slide in the right order. So, any questions?
Questions? Come first. No. You, yes.
So, thanks for a good presentation, Arjan. I didn't watch your presentation last year, but I had an understanding that Union was also a plugin-based architecture where you could choose different styling languages such as YAML, CSS, and other, and then the designer could basically choose which one to use. Is that something that's still relevant, or did you move away from that? Thanks.
So yes, at its core, it's still a plugin-based architecture. The input formats are plugins. right now, while the plasma SVG input is still there, it's not very well maintained because I've been making a lot of changes in favor of the CSS stuff, which means that the plasma SVG has kind of bit rotten. I've been trying to decide whether I want to revive that or, you know, get rid of it. Nate actually made a decent argument that eventually we may want to at least be able to support a bunch of plasma styles so that you can we can port plasma without needing to get rid of all the 900 something themes that are there. So, but that's yeah. So in that case, we would at least have two different input formats: one CSS based, one as plasma SVG based.
I'm being.
Perhaps I'm overthinking this, but have you made any performance considerations in terms of resource use, for example, when all of the style engines now include a CSS parser?
Yes, I've actually done a bunch of performance work recently. Interesting side note on the CSS parsing thing. Because the input layer is basically immutable, we can parse the entire CSS file, get that result, and then just discard the entire CSS parser again. So that bit, eventually my goal there is to actually be able to cache that so that you basically don't even need to run the CSS parser for application startup, but that's a long-term goal. So it's not. Oh, you mean the desktop style? Yeah, so the desktop style does basically it creates a Q style and then uses that Q style with QPainter to render to an off-screen texture and then render that off-screen texture as a Qt Quick object again. That's one of the things that I mentioned earlier where yeah, that implementation of the Qt Quick style is not making good use of what Qt Quick offers. Yes, that specific case, or for that case, I hope that Union will be better.
Okay.
So this is less of a question, more like a wish list, but I really hope somebody makes the Fluffy Bunnies theme with this. I really want to see that. That's all. Thanks.
Anybody else? More questions? I can get you from. It's fine, I can reach you.
You mentioned something about rectangles because some API is missing, especially for the cute folks in the room. Maybe you can drop some wishes for them.
Yeah, so I said I was going to mention that later. I forgot. So basically, if you have CSS, for a CSS background, you need variable border width, you need variable border colors, you need variable corner radius. There's a whole bunch of features that are implied by what CSS offers there. So far, I have a custom renderer using a shader that basically supports a whole bunch of that. Not yet variable border colors, but I have an idea how I can do that. So that's a feature that will be supported at some point. Also things like gradients and all that kind of stuff. Yeah, there's a lot of features there from CSS that you need for yeah, because you want to be able to offer to designers that, hey, if you want a button with weird different borders and colors and glowy things and everything, yeah, that should be possible eventually.
Thanks. Do you think that a kind of Q CSS parser written in C++, of course, would be interesting or beneficial in long term, in future?
Maybe I am not the one that's going to maintain it because I already have this thing to take care of. It's the thing is with CSS, it's one of those web standards that just keeps evolving. I think it's better to have it in a central, like shared repository of some kind. Maybe eventually we will replace the current implementation. We'll see how that goes.
Awesome. And one more very quickly from online.
Yeah. So the question is, to what extent of theming will be allowed in Union on a scale of color schemes changes to the widget style changes?
So in that regard, I showed two pictures of Discover. One with Bree style, one using a completely different style. I can maybe very quickly go back. Yeah, so this is the extent that it already allows now. So there's different border sizes, different border styles, different fonts, different colors. It's a lot more extensive than just color schemes. Eventually, I hope that the entire look of the application will be under control of Union.
Okay, we've run out of time, unfortunately. So if anyone has more questions for Arjen, come find him afterwards. everybody take their seats, please? Okay, so the next talk is by Kevin, and it's on pursuing KDE Neon Core.
All right, thank you. Thank you and welcome. So this will be an update on the KDE Neon Core project from last year. So for those who don't know me, so I'm Kevin Otens. I've been using the KDE software at the end of the 20th century, and I started contributing at the very beginning of the 21st century. Well, obviously I fell in love with the community, which is why I'm here. And I've been doing things here and there. Nowadays, so I work for Enyoka Haute Couture, where we are doing, so we're a consultancy, we're doing development, trainings, coaching, all of that. And that's how we actually bumped into this project that I will talk about. And I'm a remote worker living in Toulouse. So first, I will have a quick recap from where we were last year. So on the previous episode on that show, we talked about Ubuntu Core, which is, as they say on basically their website, it's a minimal, secure, and strictly confined operating system. It's been mainly designed for embedded systems. That's basically the immutable version of Ubuntu, supposed to be secure by design, containerized, and so on. All the components are provided as snaps, though. Even the kernel, the snap daemon, are provided as snaps. And so you get over-the-air updates with rollback for any components in there. 2 years ago, they announced what they called Ubuntu Core Desktop, which is the fully containerized desktop. And that's basically a full desktop session on top of Ubuntu Core. The idea is to have similar benefits, but for user-facing GUIs, with better security, stability, because the updates you can always roll back and you don't have the system in an unstable state. It's easier also to audit a system as long as you know the packages which are in there. And there's no inconsistency from system to system. Obviously, it comes with extra challenges compared to the full embedded use case. It's harder to draw the boundaries between the desktop components themselves, and it tends to use more storage kind of due to that. On our side, so we have KDE Neon, which is built on top of the latest Ubuntu LTS release, with the issues which come with that Harald mentioned last year. The idea being to showcase KDE exactly as we, KDE developers, intended it. And so no patches, no changes on the default settings. So rolling KDE software on top of stable Ubuntu base. And you get a very up-to-date experience. So the idea with the KDE Neon Core project was to follow similar idea, so have the same benefit, but on top of Ubuntu Core instead of regular Ubuntu. So it has a similar architecture to the Ubuntu Core desktop as planned by the canonical folks. You get the Plasma-based user experience, latest versions, that's the idea. And we provide the building blocks to package KDE applications as a snap for use inside of Ubuntu Core. Which leads us to where we were last year. So when I presented last year, that's pretty much the architecture we had. So I'm a bit too short to point to blocks. So I hope you will be able to follow along. But basically, so we covered as part of the project a few applications, all of those using what they call a content snap to have the KFC execute runtime. And then for the session, you would have the Plasma Desktop Session Snap, which is a regular application snap from the perspective of Snapd. And this one is basically empty, getting all its content for the base snap, which was just under, so the Plasma Core 22 desktop one. And so the applications and the runtime on the top right corner, they are built from source, but the content, the base snap here was built from the packages coming from Neons. Okay, so we're reusing the packages as is. And so we ran the full session confined. We had SDDM, which was not confined though. I will come back to that. And the other thing we were providing, as I mentioned, that was the building blocks for the apps, okay? I won't focus much on this part this year because that's basically, that stayed as it was since last year. We basically updated everything which is marked Core 22 there has been updated to Core 24, but that's most of the changes which happened since last year. We also had some challenges last year with quite some of the tooling, which was unfriendly to rootless containers, to say the least. So we had a VM on which we had SSH access. So in a way, that was coordinated with the KDE sysadmins. So in a way, we helped to have the blueprint for the VMs that we have now, which have been deployed by the KDE sysadmins this year. We also had GUI tests, which I mentioned as WIP up there, on the CI path to validate the applications. So that's something we completed, but I will come back to that particular part of the story a bit later. And also, so we talked about how the snap confinement works, including how the interfaces are implemented with seccomp and AppArmor. I won't get back into this. One thing I will get back into is how we integrated the systemd units, which are necessary for the session, into all of that. That part changed quite a bit. And also, we've seen some of the problems which were created by talking to systemd at startup. Again, I will come back to this, because we had a specific interface for that inside of a snapd fork that's still there. And I also had plenty of stories of how to horribly broke Queen and get black screens all the time, basically. And we had some patches to snapd, and so black screens, a lot of them. All right, so what's new? Last year, so I presented some of the challenges which I mentioned there of building all of that. There were quite a few, but I also gave ideas on how you can debug them and where the important integration points were. Today, I will focus mostly on what changed during the past year and the new challenges and opportunities coming with that. So the obvious big change that the reworked architecture, this was the obvious big topic, and I closed my talk last year on that. And we had a different target architecture in mind. So let's have a refresher. So that's the one you've just seen, okay? That's what we delivered last year. It was not ideal, and well, we had to go with that because of various constraints that we didn't control, but where we wanted to go, it's this one. So we wanted to move everything out of the base snap, basically, okay? So that we could reuse the regular core base snap. That's the intent. Because we wanted to do this, that meant that the Plasma desktop session, right, if you look at before, it was getting all its stuff, all the binaries from the base snap. Okay, if we reuse the regular base snap, we cannot do that anymore. So we need to have a content snap just for that, to provide those binaries so that the other snap can do its job. So we wanted to decouple from the base, and we wanted to be able to slice things up a bit more, because now we got the SDDM application snap, which appears in there. All right, so that's the target. That's where we got in 2025. So it's a bit of the seventh difference game. Did you notice that? I do it again. You see them? There are two main differences. So the content snap actually is there, so we really do that. But if you look, so we didn't get SDDM, and there's a reason for that, I will get to it. And if you look the core 24, we're not quite using it, right? So we're using a core 24 that we are not making, okay, which is made by the canonical people, but that's the core 24 desktop one. Okay, so that's the one with GDM and all of GNOME and so on, right, which is in there. The reason why, it's because we don't have SDDM yet. We need to have a login manager, okay? And so, well, if you remove SDDM of the picture, then you end up with having GDM because that one they already provided for free for us, right? So that's kind of an intermediate step. And there's another reason, which I will explain further, which is on the fact that we can't do this bit yet for SDDM because there are missing facilities on Snapd at the moment that which prevent us from having a proper SDDM package yet. I will get to it. All right. So the impacts, well, that just doing this, though, even though we are not at the end at the target that we had in mind, that brought some changes and impacts throughout the product, so we will talk about those now. One thing is the relationship to KDE Neon, right? Because, as I mentioned last year, we were basically using the deb packages getting from the archive for everything. But now, if I get back to this, you notice that we use the content snap, okay, and that content snap uses the KF6 runtime. And that one, last year we were building, and we're still building it from scratch, right? So by doing this, we end up kind of having to build the content snap for the plasma binaries as well, right? That reduces quite a few risks doing this. And so that means we kind of parted ways with the KDE packages in the Neon archive. Okay, we're building the KDE stuff on top. That's more convenient for several things because, as I mentioned, potentially different ABI because we're using the build KF6. And also we're changing the prefix and the deb packages, they kind of assume that they are in /USR. Well, so we could get more control this way. We're still using the KDE Neon archive though, but for the dependencies, right? Because those dependencies, well, some of them, that's for updated, they're updated faster. So we could almost cut the ties, but all dependencies outside of Qt and KDE, they are bumped quite quickly in a way, right? In a matter of months since the release of Noble, we sometimes require new APIs in those dependencies, okay? This doesn't make it easy on a stable base with a limited set of official backports. It's not quite a surprise. That's exactly what Harald was complaining about with KDE Neon in the first place. So no surprise there, but that just shows up in a different way here. So the question, obviously, is could we manage to bump dependencies less aggressively? Yes, no, right? That's thing we could think about, right? Like, for instance, Queen already depends on a very different deep display info. Is that something which we could have been more diligent in, like, supporting both APIs for a while before breaking this, or do we want to move faster? So that's something we have to figure out, I guess, as a community. If not, I mean, if we want to keep doing it like this, then it's kind of convenient to still have such an archive. And I would lean toward keeping it for this kind of extended backports because they don't exist in the official Ubuntu backports, but probably trying to keep it minimal, at least from the KDE Neon core perspective. All right. And so the problems we got, well, plenty, of course. That's a dramatic change, right? We did 3 things at the same time. We bumped to a new base distro, we moved to a different prefix, and we started to compile everything ourselves, right, for the session. So that's quite a few moving pieces at the same time. So the first one is that, obviously, well, I cannot find my binaries, and well, some stuff, like the Qt and KDE stuff, you just set a few environment variables, say, there, it's not in USR, that's fine, it's there, and it works, right? There are no big surprises there. Some of the dependencies of all of that are a bit less nicer in that regard. And so for some of them, if you dig in the code, you might find some environment variable, but which is supposed really to be used only for development purposes, so you can't really rely on that. Or you can use an extra feature of of the snaps that we didn't quite use last year, which is the layouts, where you basically create bind mounts from the perspective of the confinement, or symlinks, which exist only in the confinement, to present the right path for those dependencies. The other one was where we moved our systemd services again, so now I cannot find my systemd services anymore. So we needed a way for systemd to see them. So to bootstrap the session, there's actually a wrapper script which is provided inside of the Core 24 desktop. So we're basically doing that very ugly trick where we basically expose them in some way. We symlink to the right place, right? Hijacking one of the folders which is not used, and then we restart systemd. Now it goes a bit further because, as I mentioned last year, but that was less of a problem because of the packages we were providing enough information, but we don't quite control the systemd services because they are generated by snapd, okay? So the content, the names, okay, we control inside of our content snap. But they don't map to anything else on the snapd side, okay? Because they're all generated with snapd, some ID, and so on, right? So we can predict those, but we cannot provide them because they will be created at runtime by snapd. And that's convenient for us to still use the name, or names, right? The name of our services, right? So inside of the content snap, we're basically killing all the services files which have been created by our build, and we replace them with symlinks to places where we know that snapd will create them under another name, right? So all our services files disappear, and instead we have aliases against the snapd ones. Now the problem is that snapd, when it generates them, it does a very limited job, so it doesn't give more advanced relationships like the one we use. Like for all our services, we're saying they are part of the graphic section target. And that's gone, right? So then when you boot, and especially when you exit, that's very interesting because you have services which lie around. So next to the symlinks I just mentioned, we also have override files to be able to compensate for that and inject basically what we are missing. That's all to try to bypass limitations on the systemd side. We also had surprise with the desktop portal, and we had from the beginning most problems with it. And well, it's kind of sensitive to startup conditions, so we had to have some extra care for that. Especially because we're in a situation there where XDG desktop portal is not confined, but XDG desktop portal KDE is confined, right? So that comes with interesting challenges. And so it started after Start Plasma pushed its environment to systemd via the interface I mentioned last year. And so it tries to find libraries and config in the wrong place, right? Because XGG desktop portal is started outside the confinement. So it doesn't see the layout changes we did. It doesn't see like the build we have, right, with the libraries in a different prefix and so on. But because Start Plasma pushed the environment there, it's trying to look there and it's going to, well, that folder doesn't exist, right? So we, again, had to trick it a bit, injecting an override file just for that, and to be able to start the XGG desktop portal while resetting the environment just for this one. Also, we ship inside of the session a couple of applications, so think system settings, think K-Info Center. Okay, so for those, we have desktop files. And those desktop files, we build in a prefix, right? But then inside, because of the snaps, you can have several versions of them. You don't exactly know the path. You cannot outcode the path inside of the desktop file like we do during our build, right? You cannot do that. So instead, you have to say, well, I need the exec line to not be a fixed path, but to depend on the environment so that it actually picked at the right place at runtime. So that's why we have that bit of script there to patch all the desktop files which are provided with the session to say, look, it's not where you think it is. It starts from the snap environment variable, and it's somewhere in there, because that one is tied to the actual snap version which is running. Next to that, we also had to have some improvement to snapd itself. So I mentioned already the patches that we did last year, which were a bit outstanding, right? Now they're, apart from the systemd user control one, they are all merged into snapd upstream. So that's a good thing. But we still have that crucial one to be able to talk to snapd. There's been also other changes which were more driven by Canonical actually, because there's plenty of services inside of the core 24 desktop one. They wanted to move out, for instance, Pipewire to get it out of that base snap. But if you do that and you start to confine Pipewire, then you need the session to be able to talk to Pipewire for the screen sharing. So they changed snapd so that there's a specific interface now for desktop sessions to be able to talk to Pipewire. Right? So that's kind of where they are going. So they are trying to get UDisk2 out of the base snap as well and so on. So they are removing more and more stuff from their base snap, and we have more interfaces to support as a result. The systemd user control didn't make it upstream, and there are more changes which would be necessary to complete the transition. Okay, that's what I mentioned in the beginning, where we are not at the target yet. That's mostly because of those things. Like we would like to be able to properly describe the services dependencies, so that we don't have to do the ugly hacks that we are doing throughout, right? And there's no way to do that. We need a way also for a snap to be able to start another one, because that's exactly what SDDM does, right? If you confine SDDM, then you're inside of a snap. The whole point of a snap is that you cannot trigger something else, right? Because then that would be a problem, right? And SDDM is exactly in that situation, right? Or Plasma Login Manager or whatever. So there's a need for some mechanism to do that, and that's something which is still on the drawing board that they didn't implement yet. There's also some issues potentially with the PAM handling, which again SDDM needs, right? And you need to be able to escape just for that, and we're missing interfaces there. So that's those two things which kind of prevent us to get all the way to where we want it to be. So what else happened? Well, there's been some coordination through the Snap Store, right? Because we submit to the Snap Store. That coordination is generally a bit slow. It adds quite a bit of delay to things because they need to check which new interface you use, and as I mentioned, we had to use new interfaces that they introduced, and then they're very picky, but why did you introduce that? But you introduced it first for us. Now I just want to make use of it, right? Now, to be fair, it's kind of their job to make sure that nothing bad gets in, right, and tries to get more privileges than it should. So it's normal that they actually check that, but sometimes it can be a bit frustrating because that makes a longer feedback loop. One other thing which has been a bit of a problem for us, that the Selenium WebDriver IT Spy bridge. It's a great idea on paper. It has been a constant headache in practice. The Kate people probably remember that because we submitted some APM tests for them, and it was breaking so often on the CI that we had to remove them. So the thing is, because I'm doing other stuff in other parts of the industry, it's kind of a constant we see on other projects, I mean, professionally outside of KDE, that the Selenium tests, they tend to be very, very flaky, right? And that's not new, right? And it's no wonder why on the web space, Playwright is actually way more popular than Selenium at that point. Well, there's nice tooling around it and so on, but the core sell point of it is that they are not flaky, okay? And that's a big change. It's way more reliable. We also had more ways to engage with the Ubuntu community and the canonical folks. So I could advertise what we've been doing because we talked about it at Akademy, that I could advertise it at the Ubuntu Summit last year. And I also ended up in some architecture body around Snapd with the canonical folks to flesh out some of what do we need from a session, from a session's perspective, and especially from a Plasma session perspective, because the needs are not exactly the same than the GNOME one, so I brought that extra perspective to poke, hopefully, in the right direction. We got all the way to having a basic installer. We have ISOs and so on, which we didn't quite have last year. I'm actually happy that we helped a bit the KDE sysadmin to inform on the CI changes for the transition. And I'm coming also with bad news. It's currently the project has been, at least funding-wise, the project has been paused. And that's mainly because Canonical changed priorities internally. And that's why that impacts the funding, because we're basically funded by Canonical for that. And that means that the Snapd changes I mentioned, they are not going to appear very, very fast now, right? Now, I think it happened, so that's my personal opinion on that. Maybe the canonical folks have a different perspective, but I feel it happened in part because the needs of the desktop session, being it the GNOME one that they were working on their side or the Plasma one that we've been working on, is actually very demanding on Snapd, right? That creates, as I mentioned, right, having the right separations between the components. That's there's way more of those as soon as you're making a desktop, and they're not necessarily. That's a lot of interfaces to introduce and things to design and so on, right? And so I think we got to the point where the Snapd team was like saturated, right? That's like drinking from the fire hose with like all those demands, right? So I think that's in part why they need that pause to swallow some of that, right? Because they also have other demands for the embedded space, right? Which are different and so on. So now what, right? So I don't want to end this on a bad note like this. So the Enyoka Canonical joint project is paused, but everything we did is basically available. So what could we do with it, right? Where could we go from there as a community? So I think there's a path forward. I think we're advanced enough that with a few compromises, we can actually get to a full product which is not that far from what we wanted. The obvious sacrifice, as you can see coming, is the login manager, okay? And we could get to something where we have something in between the 2024 and the 2025 architecture, okay? So instead of using the core 24 desktop base, we could get back to our own base, but we could make it way smaller. And we would have to accept to not have a confined login manager. But then the rest would be fairly stable and safe, right? So the blueprint for that would be, so to get back the gadget and the base snap that we have, but to change them, especially the base snap, and to make that base snap extremely lean, okay? So just the necessary to bootstrap the login manager, not even containing the login manager, but just having a bunch of scripts on top of core 24 to bootstrap that without the confinement, and then you can still ship it as a snap, okay? But you just don't confine it. I have a couple of essential services, like the ones for which they didn't introduce interfaces yet, and especially XDG Desktop Portal. And then we can produce a snap for Plasma Login Manager, for instance, when it stabilizes, and run just this one unconfined. So it's a nice prospect, but there is a but. It's only worth it if we can get Canonical to accommodate us a bit for some things. Because if we do that, that cannot work with the upstream snapd, right? If you remember last year, if you remember now a bit earlier, I mentioned that we're running with a snapd fork, okay? Because, for instance, the systemd user control interface needs to be there, and this one didn't make it to upstream. There's a couple more patches that the Canonical people did on top of snapd for desktop-specific fork that is used by the GNOME session that we depend on as well. And so that means that this fork needs to keep living, right? And it cannot fall behind upstream snapd. So we need to get those patches rebased once every, I don't know, few months or something like this, okay? And the thing is, well, they paused, right? So that fork is dormant as well, so it risks to fall behind. So we would need to have an agreement between KDE and Canonical to allow us to actually do just that maintenance of rebasing the stuff from time to time, which is not necessarily a very big and horrible job, but that's still some work that needs to be done from time to time. I think that would be a good way for KDE to be proactive there in the relationship and to show some goodwill on the community side. Now, would Canonical accept that? I don't know, right? We have to ask and see, right? For me, there are good reasons to try this and pursue such an effort because it opens the door to parts of the industry we have troubles reaching today, I think. Basically, any Ubuntu core device out there with a screen could benefit from something like I'm proposing we could do, okay? And I've been surprised when I got to the Ubuntu Summit, there are actually some of that happening. And we could get something usable anywhere. Plasma could be usable, so that's TVs, kiosks, point of sales, digital signage, some industry-specific devices, and so on. Especially for the embedded industry case, that's something where it used to be like very simple one-screen stuff, and they're shoving more features into this kind of stuff, where they start to figure that, yeah, I would like to have a window manager and stuff like that. We're already seeing some of those benefits, actually, even if that's small, admittedly. But there's, like on the SDK sides of things, there's, and some of the apps, there's actually some interest. So I checked on, less for the apps, but more for the SDK. I checked for the use, so not just the runtime, which any application would pull, but really the SDK that the developers will need to try that stuff. There's actually more deployment because we got a dashboard on the Snap Store. There's actually more deployments of that than I expected, even for the ARM64 ones that Carlos made last month, I think. So that would be interesting to see what we can get out of it. I actually have been in touch with so one company which is interested in that. And well, I'm trying to see if we can get them as sponsors and so on. So I will end on a few lessons learned there. So one thing is, as I mentioned, we might want to reevaluate our GUI testing story. So at that point, I'm to the point where I completely doubt the viability of Selenium for our use, unfortunately. Even though we didn't get to the target, the architecture we had this year feels way more robust than the one we had last year. Well, I had surprises to move from one to the other, but that's a net improvement. And of course, we depend on Canonical to make progress in the Ubuntu core space. Duh, surprise, right? But that's kind of how it is. And I think there are opportunities there if we want to seize them. If you want to contribute, so the code is at the same place than last year. So the first one is for producing the images. The second one, that's a group. And under that, there's all the snap packaging happening. There's some documentation on the wiki. And of course, you can come talk to us. I also would like to thank again the team on the Enyoka Haute Couture side, and Scarlett and Carlos, who did good work with us as contractors. There's a buff which Harald mentioned, and I will mention it as well. We are doing a buff about everything which is immutable distro related, be it KDE Linux, Fedora Kinewatt, I'm not sure how that's pronounced. I just read it usually, and KDE Neon Core. So that will be Monday, 2 p.m. In room 1. Thanks for your attention. I think we might have time for maybe a question or two.
Who has a question?
How come all your systemd stuff isn't an already solved problem for your GNOME desktop? Your systemd issues that you had, how come they're not solved problems already for the GNOME desktop?
Very simple. They don't use systemd to boot up their session. No, so I think I'm 2 steps removed from the GNOME side of things, right? So I'm not sure if that's because that's a version that they still use in their base snap, which is before the move on the GNOME side. But all the calls I had with them, that was like, yeah, that's a problem we are going to have as well, right? We don't have it yet, but we are going to have it as well, right? So they know it's coming. It's just that to get their base snap with the version they were targeting, that was a non-issue back then, right?
Any more questions? Got time for like 1 or 2 more. Nope. All right then. Thank you very much. Close enough. It's fine. Okay, everyone. So up next is Alexandra, who will be presenting her presentation From Misunderstood to CEO, Breaking Bias and Building Inclusion.
Thank you. And sorry for being late. Okay. All right, so first of all, thanks for being here. I know there is always a dozen reasons to skip a presentation, like, look for some coffee or whatever. So appreciate you showing up. My name is Alexandra Betuni. I work at Externally. So just a little bit of what we're doing. Basically, we are UI software specialists or UI software doctors, as we call it. So to say, we're based in Cyprus and having our engineering teams in Greece and Cyprus. And among our services are UI UX design, embedded UI development, applications development, prototype development, QML trainings, and whatnot. This is like more or less the tools we're using. Of course, always depends on customer project needs. But since we're mostly focusing on embedded, Qt, and Slint are among our, let's say, tools of preference, we're also Slint official service partner and Qt partner. So that's it about Externally. This is a slide. It's not broken. Now, today we are here basically for something different, not to talk about tech or yes, but not in a technical way. Before we start with my presentation, so I would like to ask you something, like forget about the abstract if you have read it or not, like based on what I look, maybe I can also step here. What do you think I do? Like raise hands, designer? Yes, okay. Marketing? Okay, I like that. Junior developer? Maybe because I don't look that junior, right? Or CEO? 1, 2, 3, 4, 5, nice. Okay, so marketing is the winner here. So we're here to talk about From Misunderstood to CEO, Breaking Bias and Building Inclusion. Again, my name is Alexandra Betuni. I'm the CEO of Externally. I'm a Qt champion for 2024, a Qt developer and author. So I'm authoring 2 Qt online Udemy courses and 1 in Qt Academy as well. And yeah, let's start. First of all, why I wanted to share that. Basically, I had a bit of an unusual path through tech, so to say. I'm often introduced by my title, so CEO, which sounds very serious, by the way. But the reality is, for a good portion of my career, people mostly assumed I was the designer, not the marketing. Or marketing, which basically I listened to that recently as well. So it became a bit, of a running theme. Well, do you wrote that? It was like, I thought you were just here to observe, like in meetings, like people were just telling me, like, you're surprisingly technical, like, and, I still don't know what that one means, but anyways. Over time, then I started to notice basically that I was not the only one. So friends, colleagues, people with different backgrounds, accents, or styles, they were all, being underestimated in small, quiet ways. And, those small things, they always add up. So I thought, instead of quietly venting in group chats, maybe it's worth sharing a bit about it more openly, okay? About what it feels like, what helped me push through it, and what we can all do to make our teams a bit more inclusive, even like in these little moments. So even if one person here today walks away thinking, oh, maybe I've seen that, maybe I can do something differently, or, it's not just me, then I'll count that as a win. So that's really what these slides basically, in a nutshell, is I came into tech with a non-traditional background, coming from Greece, in Germany, being in a major automotive project, so, I was not really the profile that, someone would expect. So my career has been shaped more, by misperceptions than by actual qualifications, basically. And basically, I never expected to lead. I just didn't stop showing up. So we'll talk about that a bit later. I'm still here, still building, and now leading. So, and that's why I'm here today, basically. So, okay, let's get into it. This one basically has some animations, but anyway, I will tell everything. So when I first entered the tech world, I was just, excited to build cool stuff. Like, I didn't think too much about how I'd be perceived from others, of course. I assumed if I worked hard, it would just show. So I quickly learned that being competent doesn't always protect you from being misread or misunderstood. In my first full-time dev role, mentioned here in Germany, I remember I was at the Qt World Summit here in Berlin, like a few years ago, and this is what this comic is about. So one colleague wanted to introduce me to another colleague of his, like ex-colleague of his, and he said, like, yeah, she's working on the project with us. And then the other guy said, oh, nice to meet you. Then he like immediately said, you work on a design team, right? I was like, man, I wrote the UI code. I mean, why? And okay, that was a bit awkward, but what stung wasn't just the assumptions, basically. It was how often it happened, right? So then I quickly started to question myself, like, am I dressed wrong? Am I not sounding technical enough? Might be. Should I try to act more like one of the guys? Whatever that means, right? So then I became fluent in the art of, proving myself, right? That's why maybe basically I like beer now. I don't know. So I was starting, every conversation with a mini resume, like, I studied computer science and I had my internship in big data and so on. I started, dropping acronyms to establish, technical credibility, so like talking about pointers and objects and whatnot. Just staying late just to make it, harder for anyone to doubt, I was just pulling my weight. I remember I was leaving the office at 6:30 p.m., 7 p.m., and that was basically it was not just exhausting, it was also distracting. So basically, I just wanted to focus on, writing great code, collaborating with teammates, and learning. So instead, I was spending half of my time and energy, managing other people's expectations, basically. So, however, even though now this is still happening, I just have to say that. That's why the early days is actually, let's say, deleted. I remember earlier this year, we had a booth at a major conference here in Germany, and I just decided to, wander around a bit, see what other exhibitors do, and then I stopped by one, and the guy started, asking me, what do you guys do? And I was like, we do UI software and so on. And he said, oh, wow, that's cool. So I will come by to see what you guys doing, your demos and stuff. And then suddenly he was like, do you only have the marketing team here? So of course I said, no, I'm the CEO and one of our main developers is here as well. The guy didn't never show up. So yeah, early days, not really the case. So here's the thing. Basically, I know I'm not the only one, right? So many of us who come from non-default backgrounds in tech, whatever that means, like your gender, your origin, your accent, your age, your education, whatever that means, we learn early on that being good is not always enough. So you also have to explain why you belong. That's the problem. And the good news basically is that those experiences didn't actually break me. It just gave me material for this talk. So now I want to talk about something that most of us in this room have probably felt at some point, whether we realized it or not. I call it the invisible weight. So it's the stuff you carry that's not in your job description, right? Like having to prove you actually know what you're doing every day and on repeat. Or when you say something in a meeting and no one hears it, or maybe they just ignore you, and then 5 minutes later somebody else says the same thing, and oh, that's a good idea. So I see some of you are smiling, so yes. Already. So I guess you know what you mean. You know what I mean. So this slide behind me is basically my favorite way of explaining it. So you've got your skills, experience, and maybe even a degree or two that stands above the surface. But below the surface is where all the energy is going. So we have assumptions, like you must be the intern, or like you must be the designer, or whatever. We have stereotypes, like you're probably better at front end, right? Yeah, whatever. We have emotional labor, so like decoding what someone really meant in that email, and also deciding at the same time if it's safe to speak up, worrying if you're too direct or not confident enough. And we have the imposter syndrome. So even when no one is doubting about you, you are, right? So the tricky part is that no one sees that stuff. When you're tired or frustrated, it's easy to feel that it's just you, like nobody else feels like that. And then that you're not resilient enough or don't have the right mindset. But the truth is, like, the system wasn't designed with everyone in mind. And, some of us are climbing with extra weights to our backs, and we're still expected to reach the same milestones at the same time as others. So if you ever felt like that, like you had to work twice as hard to be taken half as seriously, you're not imagining it. It's there. And if you haven't felt it, then maybe someone from your team has already. And that's why I think this matters. So we've talked about bias in broad terms. I wanted to also share a few specific stories, some mine and some from colleagues that I've worked with. And I guess you might recognize a few of these patterns. So first of all, we have Juan. Of course, it's not Juan, it's anonymous thing, but the guy is a US national with Latin American roots, was working on major automotive projects as well. He's brilliant, like been writing embedded C++ and 3D stuff like for so long. And then one day we were both heading to a meeting room, and someone, stops him at the door and said, "Could you bring us some coffee like before the session starts?" And the guy was just a junior developer, right? So it's funny, but of course it sticks. And then we have a second story, Priya from India, another brilliant C++ and Qt developer. She was a senior technical lead at Mercedes-Benz, no less. But long before that, when she decided to actually be a programmer, then she told her family and friends about it, and the answer was like, "But you're a woman," Anyways, fast forward a few years, she was mentoring, junior engineers, leading architecture discussions, and so on. Her story is not unusual, basically, but it took effort, talent, and a lot of quiet resilience to get there. And then another one of my stories as well. I noticed when I was in meetings during my career, basically what I just mentioned also before, that I would say something and, nobody would pay attention. Then after a few minutes and somebody else would say the same thing. And, the rest of the guys were like, "Oh, that's a brilliant idea. So let's do that." I thought, I was just imagining it, but then I've read the meeting notes at some point, and I saw it was there, so I just understood that it was just ignored. Anyway, these stories aren't here to make anyone feel guilty, basically. They're here to, show patterns so we can start noticing them. So if you ever experienced something like this, you're not imagining it. If you haven't, maybe you've accidentally been that person once or twice. But anyways, the good news is that we can do better, and actually it starts with awareness. Okay. Yeah. So when we zoom out from individual stories, what do we actually see? We start to notice patterns, as I just mentioned. Not just, bad luck or isolated incidents, but structural repeating behaviors that show up again and again. So, for example, some I've experienced so far is like gatekeeping. For example, you you need 10 years of Qt. You only have 8? No, come back later, for example. Or like who gets involved into technical discussions, for example, or who's trusted to push to main, or who's trusted to, merge the paths on Gerrit, for example, or approve, whatever. So gatekeeping doesn't always look, like saying no, but sometimes it's just not saying anything at all. Second is assumptions about competence. So we made assumptions so fast in tech, like, how someone looks like, what country their name sounds like, how fluent their English is. And we tie those assumptions to how senior we think someone is, right? I've seen brilliant engineers, as I've already talked, treated like interns, and average ones treated like rock stars just because they have, the presence. Then we have communication bias. That's a fun one. Like when a woman says something directly, it's too aggressive, right? But when a man says the same, it's assertive leadership. Okay. When someone speaks up often in meetings, it's disruptive. Unless if they're a founder, then it's called vision. So these biases, show up in performance reviews and, who gets hurt. So it's like there all the time. Then we have the culture fit trap. I guess you've all heard, we're looking for someone who fits our vibe, or not sure if they fit into the team, right? So basically that's often a shorthand for they're different. So culture fit is how many inclusive hires get just filtered out before they, get even in the door. So the idea here is to aim for culture add instead, not just filtering out because, Then we have invisible labor. So, who tends to do the mentoring, the onboarding, the emotional support, like all of this work. We have to also credit that work as well, because somebody, it's not only about code, basically. And that work doesn't always show up on promotion reviews, but, it's just getting through down the table. Anyways, actually, none of that is to, blame people. These patterns aren't basically personal, are just structural. We're just let's say, programmed that way because the society is programmed that way. But once you see them, then you start noticing them everywhere. So the thing is here that you can start, interrupting them. Just speaking about me, up until this point, back when I was working, I thought if I just worked harder, stayed later, spoke less, learned faster, the noise would just go away. But the thing is that you cannot outwork bias. You cannot fix being misunderstood. This will be always there. What you can fix actually is reframe how you see yourself, right? Not as someone lucky to be there, but as someone who belonged, not in spite of your background, but because of it. So my big shift, so to say, came from a mentor who saw me before, I fully saw myself. And they told me, you're already doing the work of a lead, so it's time to step into it, right? And basically that sentence, it stuck with me. It didn't erase all the doubt, but it made me, walk differently, a bit more confident. So around the same time, I just stopped trying to lead, like the loudest person in the room, but, I started leading in a way that came naturally to me, listening before acting, connecting across silos, asking questions that others avoid to ask. And it's not because I read these things in a book, but because that's what I needed, in order to stay in tech, and it turns out it just worked. So growth isn't always loud. Sometimes it's just, show up as yourself, doesn't matter. To pretend you're something else. Now, here's the part I'd love to, zoom out a bit, because this isn't just my story, as I said, it's also an opportunity. So I'm a big believer that inclusion isn't a job title, basically, it's a habit. something we build in a way we code, we collaborate, and we communicate. So here are a few things that I've seen work. Like you should always challenge assumptions. Like ask yourself, do I expect this person to be technical or not? I mean, am I surprised when someone speaks up? Did I assume they were junior based on age, accent, or gender? I mean, why should I do that, right? Just noticing the assumption is a huge first step. So let's start from there. Then amplify quieter voices. Then if someone makes a point, that gets overlooked, to say, as Maria mentioned earlier, so give credit back to the person it came from. And this basically matters more than you think, especially in fast-moving team settings. Give fact-based feedback, like skip vague comments, like you come off strong, you're too soft, and so on. Focus on impact, not tone or personality. Ask yourself, would I say this to someone else if they looked or sounded differently, for example? And then speak with people, not for them. Like, don't assume what someone else wants or needs. Just ask them, basically. Invite them into a conversation. Like, what would support look like for you right now, for example? So all these kind of things. Basically, I believe that leadership is not, a one-size-fits-all thing. Let's stop acting like that. At the end of the day, the goal isn't to be perfect. It's just to be open, curious, and, committed to living tech better than what we found it. So, since we're here at Akademy, let's talk a bit about FOSS specifically. So open source is one of the most powerful spaces for learning, growing, and contributing, especially for folks outside traditional pipelines. I guess we all agree into that. But open doesn't always mean welcoming. So we sometimes think that because a repo is public, anyone can jump in, right? That's not the case. And it's not always how it feels. If you ever opened the PR and got silence for a week, then, or asked a basic question and got snarky reply, or felt lost in a sea of inside jokes and acronyms and so on, that open isn't always the same as inclusive. So what helps? Here's a list of a few things we could consider doing, write better READMEs, not just how to run the code, but how to participate, how to get feedback, what to expect, and so on, as a README is often the front door of your community, right? Use inclusive language when, in code and docs, avoid cultural references that assume that everybody shares your background, because it's not the case. Use language that assumes curiosity, not experience. Here's what this file does is better than this is obvious. So say hi when someone joins the chat. It's very basic, very simple, but powerful. Just one kind welcome message could turn someone into a contributor at some point. Credit contributions fairly and publicly, even small PRs, even documentation fixes or typos. Why not? This is all work that matters, and recognition builds momentum. Don't assume silence is disinterest. So not everybody has the same character, so to say. We're not all open, or a quick check-in can show people you care, and help them re-engage if needed. Avoid inside jokes. Basically, this means that if your humor requires history, then maybe rethink it, or explain it to the person first before you start joking about it. Be a welcomer, not just a maintainer. So this is not just about merging code, it's about also mentoring people all the time. And then create friendly onboarding. Use checklists or whatever you think it can make people feel like there's a place for them and a way to grow, right? This one, I like it. Mentorship isn't charity, right? It's strategy, meaning that, helping people grow basically makes your community more resilient. in a way that you don't just wait for maintainers to burn out, but you grow new ones, so that your community can also benefit from that. Recognize invisible labor, who's holding emotional tone in the chat, who's reviewing the code, and so on. Let's credit that work too. Also, inclusion is not just code commits, after all. And finally, words matter. So comment your code, like a future contributor is watching. I know I'm asking for very difficult things, but answer questions as if that person, might be your next core dev. Speak like someone is learning from you, basically, because they are. So you don't need to be a maintainer to make FOSS more welcoming in general. So just being intentional, kind, and a little more human, that's already a huge step, basically. So I won't keep you for longer. Just a few final reflections. I've shared a few stories today, some mine, some from others. Not to point fingers or just dwell what's wrong, but to say, that this stuff, it's real, it's there, but it's changeable. We don't all have the same power, but we do all have moments where we get to choose, do I help someone feel seen? Do I make space? Do I speak up or stay silent, for example? And that's where the culture of tech gets shaped, not just in keynotes, but in comments, in code reviews and conversations. The thing is that I've never, let's say, set out to be the inclusive one. I was just trying to survive long enough to do work, I cared about in my career. But here's the twist. The more I showed up as myself, the more I found others who were doing the same. And, that changes everything. So whether you're a student, a contributor, a manager, founder, maintainer, whatnot, let's build the kind of tech community we want to belong to. One where you don't have to prove yourself just in order to be respected. And even if one person leaves this room today feeling a little more seen, or thinking a little bit more bravely about how they show up, then I think we're already building it. That's it. Thank you.
Yep. Do you have any questions?
Yeah, I want to thank you for your courage. I think it's not easy, but you did it, and your analysis is quite sharp. So I think that's good, and you're strong by doing this as well. I have just a question, and I want to confirm, people work in patterns. I mean, it's hard to change. It's not even conscious. It's just as it is. But my question is, you might also have met people that trusted in you, probably just a few. Can you just, give an example or recall how this was, if you have met them?
Yeah, first of all, thanks. And yes, I did, for sure. I guess there were a few. I can count them in my fingers, like that few. They, it was just, they were themselves. That's what basically I wanted to, express with that. Just being yourself is when you do that, it doesn't cost you anything to just, give credit to someone. Just recognize their efforts or their talent. That's it. Like, don't try not to follow the patterns. Just, if you see something, then just say. I mean, even if it's good or bad, right? But because there's also, that somebody does something wrong, you can also say that. The thing is that then the other person should be in a way that, okay, accept and, accept it as feedback and so on. So, yeah, it's a bit of a complex matter, but as I said, just start with awareness and then, try to, analyze yourself when you do stuff and then ask yourself, why did I do that? And then you can be this person that you are basically telling to the other person that, you're good in that and so on, instead of following patterns. And when you do that, then the other person, of course, earns confidence and, has, a bit more power to move on, right? So I'm not sure if I answered your question.
Anybody else? Oh.
Thank you. Thank you for your talk. Yeah, I just want to say I've seen these patterns that you talk about with the women colleagues, but also myself as a migrant, where I would get comments like, "Oh, I didn't expect you would be this good coming from this place," and things like that. And I was thinking that online, when I was just a username, I wasn't being judged as much. I was only being judged on what I was saying. Maybe my English wasn't native level, kind of. So I wonder if you have a different experience when people only see your username, and something to take away from that, like being pseudonymous rather than showing up as your all the facets. Yeah.
It's a very, very short answer. My username is female. So I do. Yeah. I can use Alex instead, which often gets, that's a guy, Alex. So,
Anybody else? Okay, excellent. Thank you very much. So we have a little bit of a break till the next one. So the next talk starts at 6 exactly. So feel free to go to the bathroom, take a break, whatever you need. We'll be back. So, hello? 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 Is that working? Hi. Hello? I know, right? We're going to give everyone a couple of minutes because this is the only talk without a 5-minute gap between from what's happening next door. So we'll just give everyone half a chance because there's nothing coming afterwards. Mm. Fine, looks like I'm calling it there. Okay, so final talk of the day by Nico, and it will be on language bindings, the future of KDE, ?
All right. Before I get started, I want to address the potential elephant in the room here. If you've seen Christian's talk earlier today, none of what I'm going to say is necessarily going to be mutually exclusive with that, so let's just see where it takes us. So, to start off, I have a question for you. How many lines of code do you think KDE has? Raise your hands, who thinks we have more than 100,000? More than 500,000? More than 1 million? 2 million? 5 million? 10 million? 20 million? 1 billion? So the answer is it's around and about 15 million lines of code, which I would classify as a lot. It shouldn't come as a surprise to you that most of that is C++, with QML being the runner-up in that regard and a bunch of stragglers. So the question is, why C++? And part of that answer is because our elders decided that for us at a time where I wasn't even born, and now I have to suffer their consequences. But there's also many good reasons for using C++. First and foremost, we use Qt. Qt uses C++ for its implementation and its primary API. And for good reason. It is a very powerful and flexible language that allows you to do a lot of things in a performant way. It not only allows you some low-level access to your hardware, it also allows us to build high-level abstractions on top of that. And it's available on all the platforms we care about. It has loads of libraries and tools available in the wild. And also important for us, it's almost transparently compatible to C, so we can very easily incorporate C libraries in our development, which isn't necessarily the case for other programming languages. But there's also reasons against using C++. C++, for all its power, is a rather complex programming language with lots of features and corner cases to learn about, but it doesn't necessarily always come with all the batteries included that you might want, but it does come with a whole lot of foot guns. And that makes it very easy to make mistakes when programming with C++, in particular around things like memory management, lifetimes, out-of-bound accesses, use after freeze, and so on. And not only is it annoying when your program is crashing, it can also cause security vulnerabilities, and we don't want to be hacked, right? Right? And as rich as the library and tooling ecosystem is, it's also sort of fragmented. We have different compilers for different platforms, some of them having their own quirks. Libraries are sometimes following their own paradigms, like Qt, for example, is sort of its own little island in the C++ ecosystem, and sometimes it doesn't necessarily mix well with other parts of that ecosystem. And all of these reasons and a bunch more make C++ not a particularly attractive language for many people. And I guess most of us are here because we can at least tolerate C++ and write code using it. But as a community, we constantly need to attract new people in our communities, and it's getting increasingly harder to do that with C++ as our primary programming language. So what do we do about that? You might already glean at what I'm getting at. We need a programming language that has all of the power of C++, allows us to write efficient code, give us high-level abstractions, have a rich and good tooling ecosystem, and avoid some of the mistakes that C++ has. And, drum roll, one of the solutions being proposed would be Rust. This isn't the first time that somebody's talking about Rust in KDE at Akademy. So I'm going to spare you most of the details of the Rust pitch, because you probably have heard it before. But just as a quick summary, the core feature that is advertised for Rust is memory safety being built into the language. There's a very powerful system inside of Rust that helps you intrinsically avoid a lot of the programming errors that we make in C++. And generally, it has a lot improved language, economics, and semantics over C++. Sometimes it's compared with modern C++, but if you applied all of the principles consistently and with better defaults, and there is something to that argument, it has a rich and also fairly consistent, unlike C++, in itself dependency ecosystem. There's loads of crates for all kinds of purposes that we might want to do. And maybe the most convincing reason for using Rust in KDE is we already do it. Now, of course, we're not going to rewrite all 15 million lines of KDE code in Rust. Not by tomorrow, not anytime soon, probably not ever. So if we were to adopt more Rust, we need to have some interoperability between C++ and Rust. Rust itself comes with interoperability with C out of the box, both ways, but that's not really a great and ergonomic thing to use if you're used to C++, because C is lacking a lot of the high-level concepts that both Rust and C++ have. For example, both Rust and C++ have the concept of an optional value or a vector of items or a unique pointer, but C doesn't have that. So if you want to do the interop via C ABI, you need to take your high-level concepts, break them down into pieces that C understands, transfer them to the other side, and build that back up again. And if you do that a couple of times, it gets really boring and tedious, and you don't want to do that. Fortunately for us, there's solutions for this. One of them is the crate called CXX, which aims at exactly this sort of high-level interoperability between Rust and C++, and do it in a way that is as safe as possible. Internally, it still uses that C FFI mechanism as its implementation, but it does all of the boring work for you. And that also works in both directions. So you can call Rust code from C++ and you can call C++ code from Rust, which is exactly what we need. Then looking at Qt, Qt builds its own sort of types and concepts and abstractions on top of C++. So we need to also represent that somehow in Rust. And for that, there exists the project called CXX-Qt, which basically extends CXX with knowledge about the types and concepts that Qt provides. What it does not do, however, is make the entirety of the Qt API available to Rust. There's not that many reasons why it couldn't do that if that's what we wanted, but it doesn't right now. Whether it should do that is an interesting question to discuss. And speaking on a build system level, in KDE we typically use CMake for our build system, and for good reasons. In Rust, the primary build system used is Cargo, which is not CMake, but it's laser focused on supporting and building Rust code. So if you want to mix those two worlds, there exists a project called Corrosion, which basically adds helper functions for our CMake code to be able to build and import Rust projects. So we can have Rust builds integrated in our CMake build system. I've mentioned that we're already using Rust in KDE, so you might ask, where do we do that? One example is that in actually two different projects, in Anglefish, which is our mobile web browser, and in some places in KDE PIM, we do ad blocking, and for that we use a crate called, I think, ad blocking or ad block, which does things like maintain a list of things to be blocked. And just by being able to use that external library, that external crate, we can simplify our code a lot. But of course, that means we now have a Rust dependency in these projects. Another place where we use Rust already in KDE PIM is for HTML parsing, because, surprise, parsing HTML safely and securely and fast is actually very complicated. So somebody has done that already for us, and Rust is a language that lends itself very well for that kind of task, so it seems natural that somebody did it in Rust and we can reuse their work. And Ian talked about Union earlier today. Union internally uses a Rust library for parsing of CSS, which is then wrapped with CXX and Corrosion and so on, so we can import and use it in Union, which is based on C++ primarily. Now, what all of these things where I've mentioned we're using Rust and KDE have in common is, while we do use Rust code there, the Rust code doesn't really tend to interact with KDE APIs a lot. But the more we would use Rust, the more we would find places where that is needed. So what we need in those cases is actually Rust bindings for KDE libraries like KDE frameworks. And for that, Darshan, during Google Summer of Code, has started to develop CXX KDE frameworks, which is a project that builds on top of CXX and CXX Qt with all of the same principles applied, and adds support for using some selected APIs from KDE frameworks in Rust. In particular, it covers parts of kcore add-ons, kiatnn, kcrash, kconfig widgets, kicon themes, and kcm utils. Now, you might ask, Nico, this all sounds great, but what can I actually do with that now? Well, first and foremost, it covers some basic needs for like your basic application setup. Like you want to set up your k-about data so the application knows what it is, can show the proper name of the application, give you a list of developers. You can use it to set up translations for the project. You can use it to opt into our crash handling system, that kind of low-level application building blocks. Another thing we started on is being able to use Rust as the backend language for system settings modules. So currently system settings modules are a mix of QML for the UI and C++ for the backend, but with the support from CXX Qt, that could eventually be just QML plus Rust for a system settings module. And very similarly, I have an open merge request to add the necessary glue to write Q workers in Rust, which is also a very interesting thing because A, it allows reuse of interesting crates, and B, low-level file operation is also something where Rust can give us a lot of beneficial things. All of that said, no tool is ever perfect, and Rust being a tool is very much not perfect. Don't get me wrong, I like Rust a lot, and I think it's a great choice for many things in KDE, but it has its downsides. One of them being if you're not used to it, it can be sort of hard to approach, because the mechanism that makes Rust great and gives you all that memory safety, the borrow checker, also enforces or makes the application structure a bit more rigid and unflexible, and that takes a while to get used to. We also don't have perfect Qt support in Rust. While the basic mechanism of CXX is certainly impressive, it's far from complete. So as of right now, Qt is definitely not yet the solution for doing UI in Rust, and I'm not sure it will ever be. And all of that makes it not necessarily an ideal candidate for this sort of application topmost layer glue code that is just assign a push button to a layout, put that layout in somewhere else, and then show it as a window. And for that kind of purpose, there might be better languages out there. So what we really want for at least some of the use cases we have in KDE, we want a language that is not necessarily simple, but approachable to learn, ideally something that is widespread and people already know. It needs to be cross-platform, at least for all the platforms we care. It should have a rich dependency ecosystem, so we don't have to reinvent all the wheels. And ideally, it would have good interoperability with Qt already. And I think there's one language that checks all of these boxes, and that's Python. Qt has supported Python first party for a while now under the Qt for Python or PySide project. It's been mature and tested for many years already. And there's loads of developers out there that do already use Qt with Python all the time for their needs. And very important for our own purposes, it does not only allow you to use the existing Qt bindings, it also allows you to write your own bindings for your own C++ libraries with a tool called Shiboken. So another thing that happened during Google Summer of Code last year is that Manuel was working on sort of reviving an existing old idea of having Python bindings for KDE frameworks, this time based on Qt for Python / PySide instead of a different technology. And thanks to that work, we now have Python bindings for the majority of a bunch of frameworks, including Kcore add-ons, GUI add-ons, widgets add-ons, notifications, KXML GUI, KStatus notifier item, KUnit conversion, and KJob widgets. Very similarly, that allows you to create that sort of low-level application glue that you sort of need to make your plain Qt app into a more KDE-flavored app and make some use of some of the functionality we have in KDE frameworks. And overall, I think the story for let's make a Qt or KDE app in Python is a lot more mature than it is for Rust. So where does that leave us? I am arguing here that both Python and Rust have their strengths, have their weaknesses. They complement each other very well, I think, and I think both are a good fit for KDE, but for different purposes. Neither of them is very likely going to replace C++ fully anytime soon, simply because we have way too much existing C++ code that we're not going to rewrite. For Python specifically, I think it makes the most sense at the sort of topmost application layer right below QML or in combination with Qt widgets. Python in general is very good, and sort of its primary purpose is tying together modules that are written in other languages. When it's used in that way, the raw performance of the Python interpreter is not really a topmost concern. But if you're doing some sort of intense data crunching, Python is probably not going to be the right choice, and it might make more sense to do it in, for example, C++ or Rust. While it's now possible to use a bunch of KDE Frameworks API with Python, one part of the overall story that still needs attention is the distribution of it, because particularly with Python, that's a very challenging topic in itself. And in particular, something we are missing right now is the ability to just do pip install kcore add-ons, for example, because we haven't packaged things up to work that way. But that's something that Python developers expect to work. And as Christian mentioned earlier today, we have to meet developers where they are and give them the ability to work the way they are used to. And if we just say, well, if you want the Python bindings, go install them from your Linux distribution, that's going to be important for some, but it's not going to satisfy all of them. So that's something we still need to look into. As for Rust, there's this meme going around with rewriting everything in Rust. I do not think that this makes sense for KDE, because if we tried, we would probably not finish before I retire, and I'm not that old yet. I think where Rust really shines or can shine in KDE is towards the lower parts of our stack, like file parsing, file handling, input handling. Where it doesn't shine is application layout, shoving push buttons around. I think it makes a lot of sense where we can leverage the existing crates ecosystem. So if we have a task at hand and there's a crate for that and no equivalent C++ library, that's a very solid use case for using Rust. In particular, it makes sense where the thing we're doing is security sensitive, like parsing images, for example. But even for those cases, it's not necessarily clear-cut if rewriting existing code in Rust is a good idea, but I would argue that whenever we rewrite or create whole new modules or subsystems or just larger parts of the functionality, then we should really consider whether Rust is a good fit for that and whether the interfaces between the new code and the old code lend themselves to that kind of interoperability, or if that would be too complex. And I think it's really often a case-by-case decision on that. Now, even with Python, we don't have bindings for all of the libraries we have, and I don't think it's really even feasible to do that, because it's just a lot of work, and sometimes I don't think it's even necessary. It doesn't really make sense when we want to, for example, parse iCal calendar events to create a Python or Rust wrapper around kcalendar core, which is a C++ wrapper around libical, which is a C library that does the actual work. So I'm very sure that there are great solutions for reading and writing iCal files natively in both Rust and Python. But I'm also skeptical about just blindly adopting them, because there's absolutely no guarantee that they're going to be better than kcalendar core, what we have right now. So I'm very hesitant about just blindly replacing everything that we have with somebody else's code. Creating bindings or wrapping our code in another language makes a lot of sense when the functionality we are talking about is exclusive to KDE, like Kio workers, for example, or really a lot of other things in KDE frameworks. It also makes sense if the type we're talking about is used in the interface of another type. For example, kconfig is not only used directly to read and write config, it's also used in the API of other types to exchange config data. And if we want to wrap those types in another language, then we probably also need to wrap API from kconfig just to have the APIs representable in the other language. And sometimes maybe we have some functionality that isn't necessarily inherent to KDE, but we have the only implementation out there, and there it might just make sense to implement that by wrapping a KDE library in another language. Now, there are some challenges, naturally, with everything I've talked about. One thing I very much like about KDE as it is right now, there is a good amount of technical consistency between various KDE projects in their coding style and practices, how they do dependency management, and various things like that. And if we now mix a couple of additional programming languages in there, that jeopardizes this technical consistency, and it would make it potentially less likely for people to being able to quickly move on between different KDE projects and effectively contribute to them. Creating good bindings for Python and Rust is also not an easy task, as Christian also mentioned today, and it takes a lot of work, and not all API concepts are necessarily representable in another programming language, and generally it's not a trivial process to do. It's not rocket science, but it's also far from approachable for an average newcomer. And one of the things that we risk here is that if we expect people to come into our community, right now we expect them to be able to at least somewhat work with C++. If we throw in Rust into the mix, we're not only expecting people to be comfortable with working with C++ and Rust, but also the interoperability of those. And what we're really risking here is a sort of social community fragmentation where people will say, oh, I wanted to contribute to this project, but it's written in Rust. I don't know that. I don't like that. I don't want to learn that. I'm just not going to bother. And that would really be a sad outcome and something we should very much try to avoid. Also, whatever we do with our approach to using other languages in KDE, we need to make sure we have really solid documentation about how all of that works, not only from an API documentation perspective, but also from a perspective of, okay, how do I do bindings? How do I package all of those things so I can distribute them? And finally, it sort of raises interesting questions about our identity as a community. Do we identify ourselves as a community that creates C++ software? Personally, I would advocate that there is more that ties us together as a community than our shared choice of programming language. But what exactly that is something to potentially discuss over a beverage over the next couple of days. And with that, I am at the end of my presentation.
Question.
Thank you. This was very interesting. I am interested in knowing if you have any specific thoughts about how we can address these challenges, because when I see those bullet points, I feel like I see a little bit of that having already happened with the split between Qt widgets and Qt quick, for example. And I'm wondering how you think we can maybe address that sort of thing or prevent it from worsening over time.
I think the best thing we can probably do is just education. So when it comes to people not knowing a certain programming language, then showing them, here, this is how you can learn about it, this is how you can learn about the interoperability, having solid documentation and guides on how to do it, because we are all here because we are capable of learning things like programming or contributing to KDE. So everybody in this room who can write C++ is also capable of learning Rust. It's more of a mental thing to unlock the desire to want to learn it, or just making sure that people don't refuse to learn out of principle. So I think really educating and giving a low barrier to this education is a way to go. And another thing would probably just be showing people the benefits of doing that, showing people that, hey, by using Rust, we are able to create software that crashes 90% less, or we can do these awesome things. Unfortunately, there will probably still be some people who will just refuse to do any of that out of some sort of principle. But I think that's a problem that we have regardless of what we do with anything. And maybe sometimes the best thing is just to ignore the haters and do our own thing. But it's a very tough balance because, as I've tried to get into, there's a lot of legitimate reasons why people might be skeptical of a language like Rust or Python and actually prefer working with C++.
One of the challenges regarding the identity and community that I know it's a kind of worms, but I have been personally facing is that, for example, the Rust community kind of lives on GitHub. And at least from my experience, the Python community now is living on Discord, which I know, proprietary software, you know, the devil and everything. But I think that one of the key thing here is that we need to think of like what will be the middle point, because it will be, in my own experience, it's impossible for me to bring some of the Python developers to Matrix or IRC. And similarly with Rust, I mean, every time that I am saying, yeah, we can have this thing called Gerrit, they say, no, what do you mean? Everything, the Rust ecosystem is on GitHub. So we might need to find together a way of like meet in a middle point. So what are your thoughts on that topic?
Yeah, tough topic, good question. Sort of unrelated to the languages specifically, because that's just a problem in general that some people expect us to be on Discord, for example. I think one thing we can do is, well, not outright move to these platforms, but offer a good enough alternative. So just making sure we have something relatively modern like Matrix and not are stuck to IRC, which would be a much bigger obstacle than Matrix, for example, would be. And then the other thing is we probably don't want to attract Python developers for the sake of, hey, you can write Python here instead of there. I think what we really want to do is make sure our product, the actual end result, is what attracts people into wanting to contribute. And I think if we succeed at that, then I think at least a good amount of people would be willing to not use GitHub and instead use our GitLab or use Matrix to be able to do that. So I think put the product first and everything else is implementation details.
So when talking about community identity in KDE, I remember a few years ago we had a long discussion about the KDE vision, KDE mission on the KDE EV mailing list, I think. And yeah, I don't know if everybody's aware of the KDE vision. So this basically leaves out Qt and C++ completely. And this was the conclusion of our community back then. In case you have internet, you could even show it.
I can say something. Yeah, that is a very good point. And I definitely agree that leaving specific technologies out of division was the right call because, as I hinted on earlier, programming languages or frameworks are just implementation details and the end user doesn't care. And if the future of KDE means I'm gonna write Swift tomorrow, then that's okay with me if that means we can create awesome software.
So it's not a question, I just want to complete on that and what you just said. So there are three bodies which are basically the base, the constitution of KDE, right? So there's the manifesto we worked on, and there's like no mention of technology at all. There's the vision, same thing, that doesn't mention C++ or Qt. And there's the mission. In the mission, there's one single mention of Qt in practice. But, no, let me finish. But the sentence is interesting. There's basically just somewhere in there saying that to implement the mission, we will have the help of KDE and other technologies as we see fit, basically, right? So, yeah, it's, I mean, from constitution point of view, it's a fairly open field, right? There's no problem there. I'm not very worried about the community identity. The technical and social fragmentations, that's more, and the burden of the complexity of that, that's more where that will be, I think.
Do you like to replicate? Regarding the community identity, as far as I'm concerned, I think it's a lot about freedom itself. Maybe it's a philosophical question. Freedom and the responsibility of resource management, garbage collection, is something where pure C has lots of wisdom in it. But if you take something from the material world, you have to give it back sooner or later. But Rust at the same time has lots of wisdom about the lifetime of things and when you want to access them. So that's an educational aspect of the programming language itself and how it is implemented. So Swift or whatever language probably doesn't care about resource management because they have lots of financial resources to buy expensive hardware to handle the shitty software, which most people don't have. So how do you think about this aspect of the language?
I have not thought about that. I'm cautious about drawing definitive conclusions about life just from memory management of programming languages. One thing that maybe is more interesting to look at from a community perspective. For example, Rust has done a very good job at not only including but celebrating diversity in their community and diversity of people. And I think that's something that KDE isn't bad at, but maybe something we can also learn from in some ways.
So first of all, thanks for all the good words about the Rust community. I'm the ex-lead of the Rust community team. But one of the things I'd like to encourage you is like, don't see the Rust community or any programming language community as a solid block. And in particular, a problem when people look at Rust is they see the Rust project as the community, which it isn't. And even though the Rust project, for example, meets on Zulip, for example, the Rust embedded community meets on Matrix. Like the number of chat channels I have just for that reason in chat programs is amazing. So the thing I would like to encourage you, what is Rust at KDE and how can Rust at KDE then interact with the relevant bits of Rust? I think that's an important model to make.
Yes, thank you. That is a very good point, because for all the positivity within the Rust community, there's also less positive aspects of it. Like, for example, some parts of the community are extremely zealous about advocacy for Rust and telling everybody, if you're not using Rust, you're unsafe, you're a legacy, you should be rewritten. And I don't think those parts of the Rust community are doing the overall community a favor by that, because I've seen it firsthand in KDE that this has discouraged people from embracing Rust more in some ways, and I think that's sad because there's a lot of positive things to be gained from Rust. And I'm also going to use this as an opportunity to pitch two things of mine. Next week during the BOFs, I think on Tuesday, I'm going to do a session about diving into some of the more technical details about the Rust interoperability and how that looks for KDE frameworks, because I have not shown any code on these slides, so I want to give you the opportunity to take a bit of a peek into what we have right now and I explain a bit how that works and how to contribute to that. And the week after that, in Berlin, there will be Oxidize, which is a conference about Rust, where I will be giving a talk where I'm gonna tell the Rust people all about the things we are doing in KDE and our somewhat at least unique perspective on Rust and the future of Rust and C++ interop.
So why did you choose those two languages to talk about? I mean, look at JavaScript. That's where all the developers are, and it's already like part of the QML.
So one part of that answer is because those are the two most programming languages that have the most existing work already in terms of things to build on, like PySide and CXXQt. JavaScript is a bit of an interesting one because, as you say, we already sort of have that in QML, but I would argue not in a way that is terribly useful because first of all, a lot of the APIs that exist in Qt are not really exposed to that world or exposed in a somewhat limited way. That's something that could be changed, but whether that's the right approach, I don't really know. Because as things are right now with QML, you have a naturally fairly strict separation between this is the QML UI layer and this is the business logic layer below. And that's generally a very good thing. And doing too much JavaScript within QML could jeopardize that. Another aspect is that, for example, a lot of the JavaScript work that is happening is actually done with languages like TypeScript that build on top of JavaScript. So we have yet another language and system and so on that would need to be incorporated. So it's definitely something that I can see working if somebody puts the work into that. It's just not a thing that I have personally chosen to do. But if somebody wants to experiment that and report back, they are perfectly welcome to do so.
So quickly from the chat. So we had one question, which is, did you hear about the Qt Bridges initiative? Both of those talks for the chat have referenced each other. So we had Christian earlier. And then the actual question, what can be the best approach to use something like Bridge or otherwise to build apps with idiomatic Rust, i.e. without interop quirks, with minimal bits of glue, CXXQT, to use existing KDE libraries with that?
If they find out, please tell me. I mean, one way to approach that from the perspective of people coming into the whole thing is just us creating thicker layers of abstraction and having basically a lot more pre-made idiomatic Rust feeling components that maybe wrap existing C++ code, maybe re-implement existing KDE concepts. Like, for example, instead of wrapping kconfig C++ API in Rust, we could write a Rust library that just is file format compatible with kconfig, and maybe the API would be more idiomatic and nicer to use in Rust, maybe not. But again, that comes at the cost of doing a lot of more work ourselves, and it doesn't necessarily make the whole thing more approachable for people who want to do things that are not yet already covered in existing solutions. So, tough question, because yeah, it is a very important point that even when you create bindings, that does not necessarily create APIs that feel natural and good to the people on the other language side.
Awesome. So that is the end of our end of the talk and the end of our day. If we can once again thank Nico. Thank you very much, everybody.